This course is based on the official Dart documentation and the amazing book Dart Apprentice. So, have you ever heard of terms such as null-safety, factories, interfaces, inheritance, abstract classes, mixins, asynchronous programming, singleton patterns, and somehow you don't know what they mean or how to use them? Or maybe you never heard of those terms, or maybe you never wrote a single line of code in your life. Well, regardless of what's your case, this course is for you. If you are watching this course, chances are that you are interested in Flutter development. And one of the most common problems with us Flutter developers is undermining the importance of really understanding how Dart works has in our Flutter development careers. Helping you understand the power of Dart and how Dart works is the reason why I created this course. We are going to start this course from ground zero. I will show you how to get the Dart SDK up and running into your local machine, and then I'll show you how to download and install the text editor that we are going to use called VS Code. After that, we are going to have an introduction to programming. We will define concepts such as variables, functions, control flows, and loops. I will also take some time to teach you best practices in terms of software development such as dry. Then we are going to talk about collections and operations that can be done into collections, different types of collections in Dart, and we are going to discuss when and how to use each one of them. After that, we will have an introduction to object-oriented programming. We are going to define classes and objects and different types of classes. We will talk about constructors, the different types of constructors, and when or how to use them. We will briefly talk about design patterns, where we are going to build a singleton class. After that, we will talk about more advanced stuff such as inheritance, types of inheritance. We will talk about interfaces, abstract classes, mixins, and so much more. Another topic that is going to be super important is null safety and nullability. We are going to explain what's that null safety and why is it so important. At the end of the course, we will talk about isolates and asynchronous programming. I will explain you how it works in the context of Dart. And these are just some of the topics that we are going to touch in this course. The course is made for developers in any level. You can be a developer who never wrote a single line of code in Dart, or you can be a Flutter developer that has one or couple apps already built. I believe that there's a thing or two that you can benefit from by watching the course. The lessons of this course are constructed independently from one another. That means that you don't have to watch the course sequentially. You can skip to the lesson or section that interests you. Hopefully I was able to convince you to enroll to the course, and if yes, see you inside. Now, depending on when you watch this video, some stuff here might be outdated because Dart is a language that's evolving, right? But that's not a problem because you can watch the updated version of this course for free on Skillshare. And what's Skillshare, you ask? Skillshare is the sponsor of today's video, and it's an amazing online learning platform where you can go to improve your skills. They have classes on a variety of topics from design to photography to finances, coding, and so much more. If you sign up using the link in the description, you'll get a month of premium access for free. And that's valid for the first 1,000 people to sign up using the link in the description. And you can do that and access this course and my other course, Flutter Web. And yeah, that's a very good deal if you ask me. Thank you Skillshare for sponsoring this video. Before we start the course, a quick note here is that you can find all of the source code here on this repo. And the link will be linked to the description of the course or the description of the video. Once you have clicked on the link, you can just click on this button here and download the zip file. And after you have downloaded the zip file, if you open the project 1 folder and open the bin folder, you can see that we have a bunch of folders here. Basically, for every single lesson of the course, you'll have code associated with the lesson, and you can open the respective file here to follow along. This is going to be super useful if you face some bugs, because you can use this to kind of troubleshoot your code. When it comes to running your Dart applications or your Dart programs, you have two options. You can run them from the browser or you can run them from your local machine. If you run them from the browser, you do not have to install nothing. You just have to go to a website and it's called dartpad.dev, this one here, and you can run your Dart code from your mobile phone, from your tablet, from your computer. It doesn't matter. The other option is downloading the Dart SDK, installing some software called IDEs that will allow you to actually run the code on your machine. For this course, you can follow along on this website. Let me open up the website, by the way. And this is the website, the Dartpad website, you know. And here you have template Dart code. I don't know if you guys are able to see because this is super small, but it doesn't matter. And here is how you run, and here you get the result. So as simple as this, you come to this website, and every single thing I am going to be showing and teaching you guys on this course, you can just run everything here, right? But I would advise you to actually go ahead, install the SDK, download all of the software, and develop your programs on your machine, right? And to do that, you can click here on install SDK, and this will take you here. All right, this is the official Dart website. The first thing for you to know here is that if you already have Flutter installed, and Flutter is a framework that was built using Dart, you do not have to install the Dart SDK, because by default Flutter from the version 1.2 comes with Dart installed, right? You only have to explicitly install Dart SDK to your machine if you want to build Dart apps that are not Flutter apps, right? If you're trying to do these three things here, right? On this course, we are going to build a Dart app that it's not a Flutter app, so we need to actually download Dart. Depending on your system, you will have different instructions here on how to install Dart on your computer. If you are on Linux, you just have to copy these commands here. Super straightforward, super simple. If you are on Windows, you will have to run these commands here, and if you are on Mac OS, which is my case, you'll have to run these commands here. The thing here is, for example, for Windows, you'll have to install this. Unfortunately, I am not running a Windows machine now, and I do not have a way of showing you guys this, but it's super straightforward. You just have to click here on install, and just click next. You're going to install everything, and after that is installed, open the command prompt, cmd, copy and paste this command here and this command here, and this will get you ready to write your Dart code. All right, Linux, same thing. For Mac OS users, first of all, you have to install Homebrew. I already have this installed, so but all of these are super straightforward steps, to be honest. Copy this code, paste it to your terminal. I already have it installed, so I'm not going to paste it, but you would copy this and paste it here, hit enter and continue. Right, basically to get everything up and running, this is what you would have to do. Now after you have installed Dart on your machine, what's the next step? The next step is actually checking if Dart was installed successfully. If Dart is installed on your system, you just have to open your terminal. On Windows, you would have to open the command prompt, right? And to do that on Windows, again, is the start button, and then type cmd. That will allow you to open the command prompt. After you have that, the code you're going to use to test is Dart version. So there was a typo here, Dart version, and here you have the version 2.12.0. You may have a different version depending on when you watch this tutorial and follow this step. If you have an error here, that basically means that Dart is not successfully installed on your computer. What you can do is you can send the screenshot of the error on the Q&A section, and we can help you troubleshoot the issue. Well, now you have your Dart SDK installed on your computer and you are ready to go. The next step here is to download Visual Studio Code, because that's the text editor, or that's the software we're going to use to run the code. So you just have to download here. Depending on your computer, you may have something different here, and depending on when you're going to watch this tutorial, this website may be changed, but that's not important. As long as you can find the download button, you have to download that. After downloading, you will get an executable file. You just have to install this software. Super straightforward as well. Just have to double click on the downloaded file and then hit next, and you will have VS Code installed. Now if you open your VS Code, you may have something similar to this or something extremely different. It doesn't matter right now, right? And this is like this because I changed the theme and I've been working with VS Code already, and probably you're not going to have all of these options here as well, but don't worry, don't have to worry. The only thing that you have to do here is clicking here on extensions, and then you will type Dart. Click on install. I already have it installed, right? And what this will allow you to do is allow your VS Code to run your Dart applications, right? So this is extremely important. You have to follow this step, install the Dart extension that will enable you to run Dart code on your VS Code, right? So this was super simple, super straightforward, nothing too complex, nothing to worry about. And that was it for this lesson. We'll continue on the next one. On this video, we are going to run Dart code. Now that we have the extension installed into VS Code, we can start running our Dart programs. And to do that, it's super simple. What you will want to do is just select file, then open. This will allow you to open a new file, and what you want to do is create a new folder, and this folder is where you will save all of the files of the whole class, the whole course, right? It doesn't matter where it is located. On my specific case, I already have a folder created and I called it Dart course. As you can see, it's an empty folder. Right, let's create what's called hello world. Hello world basically is the first thing you usually write on a programming language. Now here in VS Code, to create a new file, you just have to click here. You have new file. If you hover on this button, you have a new file, and the other option is to do file, new file, or command N or control N, right? Since we are working with Dart files, the extension has to be Dart. Basically here you have the name of the file, then you have .dart, and this is what tells the IDE, or what tells this software that this is a Dart file. Good. The icons you are having, or the icons you use on the VS Code that you are using, may be different, because here we are using a custom theme. The hello world program that we are going to write here will print hello world, right? You just have to code along with me. Don't worry about not understanding this. Here is where your Dart code starts. Every single time you start a Dart program, you will have this function here. And since we want to display something, we need to print. So just write print, and what we want to print is hello world. Here you have the code. Now you have a lot of options to run this code. First of all, you need a command S to save. You can click run, And if you do so, you can see here hello world. Another option is clicking here, run code, hello world, or you can press F5, right? So this is basically it. This is how you start with your Dart program. But this is a single file. Let's imagine you want to create a Dart project. And usually you will want to create projects. And the advantage of projects is that they come with a built-in structure already made. And how you do that, it's super simple. Click on terminal, new terminal. Make sure that the directory here, the last thing is Dart core. So this directory here is the directory that you're currently in here. And then to create a Dart project, you would type Dart create and the name of the project. And remember that the name of the project can be anything. Here we are going to call this project 1. Oops. And if you have a look here, you'll see that we have a new folder called project 1. Now to access this folder, you just need to open up this here. And as you can see here, we already have a bunch of files and directories here. We are going to go through this on the next video, don't worry about that. But if you open the bin folder, you'll see that we have a file called project 1, the same name as the name of the project. You can click on this file and run it, and it does the same thing. You can write your name here just to make sure you are running this here, not the previous code. Here you have it. Right? Good. Now, we have all of this done. What we need to do now is to understand this structure here, because most often than not, we will need to create Dart projects, not single files. I can even delete this. So on the next class, on the next lesson, I will explain you the structure of a Dart project and the use of everything here. And now we are going to understand this as the class progresses. Don't worry about this for the moment. Just be happy because you have your project here up and running. Beautiful people, welcome back to the course. On this video, we are talking about project structure. So here we have a .dart tool, and here we have package config. Basically, this is a configuration file. If you open this file, you'll see that you have some information relevant to this project, like the project name, the root of the project, the version of Dart used, and all of that stuff. But usually you're not going to need to open this because you're not going to change nothing. We have the bin folder or directory, and the bin folder contains the Dart files that we're going to run. On our case, we have here project1.dart, and this file was created automatically, and it has the same name as the name of the project. Then we have git ignore. If you are planning on hosting this project on a platform such as GitHub or another Git platform, you may need to ignore some files. If you want to host the project, sometimes you don't want to publish or make all of these files available. So you're going to ignore some of them. For example, here we're ignoring the packages, Dart tool, and the build. Analysis options.yaml. What this file will do, this contains some logic that will help to analyze your code or the code you write, the Dart code you write, and find errors if you have any errors on your code. And this process is called linting. right? Change log. On this file here, let's suppose you build this project, you have version 1, and then you build a second version of the project where you change couple features. On this file is where you would keep track of all of the features that were changed and everything that's new. You would keep track of that here. You would manually insert those changes here. We have pubspec.yaml. This is a configuration file as well, and it keeps track of the packages, external packages that we use on the project. And not just that, we have here the version number of the SDK, the version of the SDK of the project, description of the project, and the name of the project. README file, this is a very popular one, and this is basically a file that has a description of the project, of what the project does or how to use the project. So yeah, that's basically it. That was a very rushed overview, but I think that that's everything that you need to know as far as this structure goes. Hello beautiful people, welcome back to the course. Well, we've been working with Visual Studio Code for like 2 videos now, but I would like to do one video, which is this lesson here, where I basically explain the windows, the different windows here on Visual Studio Code. I think that would be very important for this class, for this course, right? The first thing that we have here is called the activity bar, and depending on what you select here, this will define what's displayed on the sidebar, and here is the sidebar. If you click here, you can hide the sidebar or display the sidebar. The search for version control, here is where we run the code for extensions, and when you install new extensions, sometimes you will have new icons here on the activity bar, right? And this is our sidebar. So we have here activity bar, sidebar. Depending on the operating system that you're using, on Windows you usually have a top bar here as well, just like this. Here we have this window where is the code, not usually actually, here is where we write the code, and this is called the editor, and it makes sense because it's where you edit the code. And down here we have the panels, and here we have the debug console. You can open the terminal, outputs, you can check for problems as well. At the very bottom of Visual Studio Code, I don't know if you guys will be able to see on this video, but if you open the software, you'll be able to check the status bar at the very bottom, right? So this is Visual Studio Code, and those are the windows that you are going to be working on, right? Yeah, so this was basically it. See you guys on the next one. This is an update video that I had to add at the end of the course. Depending on when you watch this course, if you click on pubspec.yaml file, the SDK version here might be different. What I want you to do is change the SDK version that you have to this one here. So just copy this line here as it is, exactly like this. When we start talking about nullability and null-safety, you'll be able to change to the version that you currently have. And don't forget to save the file after you have updated this line here. Hello beautiful people, welcome back to the course. On this video, we will talk about statements, expressions, and operations, right? Let me create a new file inside of a folder just to organize this. Let's call it 1, and here I'll create a file. And that's how you usually name files in Dart, right? Well, let's start with statements. So what's a statement in Dart? Statement is an instruction. It's a command. With a statement, you're basically telling the computer to do something, to execute something. And such example, or an example I can find, is print. For example, we already worked with this. You may need to write everything inside of a main function. Can remove this, it's not needed. So everything is going to be done in here. I will write comments here, and commenting basically is the ability of describing code in human understandable way. And what's special about commenting is that, for example, if you add this, the compiler is not going to run this code, or is not going to recognize. You usually use comments to describe what a code or piece of code does, right? And to use comments in Dart, you just have to start with double slashes, and then you can start writing the comment on that line. So we have here statements. Again, as I was telling you guys, a statement is a command. Here we are telling the computer to print something. And in Dart, every single statement ends with a semicolon. If you delete, you're going to have an error. And here you have it. So basically here we are telling the computer that this statement starts here and ends here. Let me copy and paste. So the computer will understand that these are two different things, that this is one statement and this is another. Other than statements, we have expressions. And don't worry about these messages. I'm getting this because I have some extensions that you guys do not have. You probably are not getting this, so don't worry about them. Expressions are not commands. Expressions are things. They do nothing. For example, if I have a number here, let's say 4, like this is an expression, right? It's a number. If I have a text here saying this is an expression. So basically, expressions are things that do nothing, right? I know it's a bit hard to understand, but yeah, it's basically that. Now, it's not every single time that a statement will end with a semicolon. This is only for simple statements. If you have complex statements, I can add here complex statements, something like this. I mean, I don't even have to write an example. We can have here, I can use this file, this function, the main function, as an example. This basically tells the computer where to start executing the code. But at the end of this statement, we do not have semicolons. That's because we have these curly braces, and usually when you have curly braces, you do not need to add semicolons. And if you do, you are going to get an error because it's not expecting to get a semicolon. So that was it about expressions. And you can have things, operations like this one here, and this is an expression, right? Now let's talk about operations. And when I say operations here, I'm talking about arithmetic operations, just like this one. And for the examples that I'm going to provide here, we are going to do this on numbers only. Just like in math, we have the basic ones here. You can add, you can subtract, you can divide, multiply. So here we have addition, subtraction, multiplication, and division, right? Let's do something nice. If you run this code, nothing is going to happen. But if you want to see the result of this, you'll have to copy this and paste it inside of print statements, right? Now here we have it. Let's run the code. First of all, you have to save it, and this is how you save. Click here to save everything. What happened here is that I ran the code, but nothing changed. But that's because this is minimized. You just have to drag it like this. And you can see here, hello world 2, 1 plus 1 is 2, and all of this is correct. Now, something that I want to show you here, where we have 4 divided by 3, you have this number. Sometimes you just want to get the integer value, and to do that, to get the integer division, you just have to add this sign here before the division symbol, and the result is going to be 1, as you guys can see here. So this was it in terms of expressions, statements, and operations, and these are the basic ones. You can do a whole bunch of mathematical operations here, but let's stick with the basic ones. Most likely you are only going to need to use these ones. So see you guys on the next one. Hello beautiful people, welcome back to the course. On this video we will talk about variables, constants, and a lot of stuff in between. But before we start, on the previous lesson we talked about operators, arithmetic operators. I just want to remind you guys that arithmetic operators are not the only type of operators, but I don't want you to feel like you have to memorize a bunch of stuff. My goal here is to make you understand. So we will talk about other types of operators as we need them, right? So we have this here. This is an example of an expression, and we talked about this on the previous lesson. What happens is that most times you will need to access this value somewhere else in the code, right? And having to type 1 plus 2 every single time in the result of this expression is time consuming. So we have containers, let's call them containers, that can store values, right? And on those containers, we can classify them as variables and constants. So variables, think of variables as containers that can store values of the same type but can change the value, and constants, containers that can store values of the same type but the values cannot change, right? So let's start with an example. So here we have one example. This is a variable, and what's happening here is that we have type annotation here. We are defining the type of this variable. This is not needed to do in Dart, but I feel like it's important for me to start by showing you this, and then I'll show you other ways of doing stuff. But usually the structure is the same both for constants and variables. First of all, you have the type of value that you're going to store, and here int stands for integer, so we want to store an integer. Number, which is the name of the variable, and here we have the value, right? So here we have assigned this expression to this variable, and here we have the equal sign, and this is called an assignment operator because you assign values to variables or constants here. And as you can see, when we print here, we have 7 and 3. So what's nice about this is that, for example, we can do something else. And as you can see now, to access these values, the 7 and 1 plus 2, now we just have to reference the variables or the name of the containers. Now here I created another variable called result2, which will be equal to the first result plus the number, which is this. But we can actually change the value of a variable. So if I come down here and I type result2 will be equal to 10, for example. If I run this code, let me change the value here so that you guys can understand what's happening. So if I run the code, here we have the result of the operation here, result plus number, which is 3 plus 7, which is equal to 10. But after that, we are manually assigning a new value to this variable result2, which is 4. That's why here when we print, we have 10, which is the result of this expression here, and then we have 4, which is the value that we assigned manually. Here we have the most common data types in Dart. Unlike other programming languages, Dart doesn't have what's called as primary data types, because every single data type here is an object, right? If you're new to programming, that didn't make any sense, but don't worry, you'll understand more about objects in future lessons. But anyways, for numbers, for representing numbers, we have int for integers, double for decimal points, and num can store both types, and num is the parent class of the int and the double. We have Boolean to express values as true or false. For example, I have here, do I love Dart, and the value is true. We have strings to represent text and characters, and we have list to store a list of things. And then here I have some basic rules of naming variables, because as you can see, there is some rules. This is not random. Variable name can consist of letter and alphabets. Keywords are not allowed to use as a variable name. What's a keyword? Keyword is basically a name that it's already taken, right? In simple terms. For example, we have bool here. The Dart compiler already understands bool as a data type, and you cannot use that data type as the name of your string. So you cannot use names that are already taken by the language. Blank spaces are not allowed, obviously. First character of a variable should always be an alphabet. Just like here, we always start with alphabets. Variable names are case sensitive. That basically means that having name here in lowercase letters and have name in capital letters is not the same. Special characters are not allowed. You cannot have hashtags here, the @ symbol, and all of that. The only special character, or one that is allowed, is the underscore. And another one on how you, for example, if you see here, you have do I love Dart, and the way you write these long variable names, you use what's called a camel notation. So you start with a lowercase, but when you start a new word, you have to start with the capital letter, just like here. So this was variables in a nutshell. Let's proceed. About type safety. Type safety basically means that once you define a variable type, you cannot just change it afterwards. If you define a variable to be a string, you cannot then assign an integer to that variable. On the first example here, we have string, my name, which is Santos. If I uncomment this line here, you'll see that we have an error, and the error says the value int can't be assigned to a variable of the type string. And this is super awesome because it's going to save you a lot of times and avoid a lot of bugs, right? But on this case here, we have phi, which is of the type num, and the type num can be both an integer and can be a double, right? So here we have the phi, which is 10, and then we assigned a new value to the phi, which is 7.7, no problem. Now, you can define variables without having to have here the data type explicitly, right? And as I told you, the keyword to do that is var. So we have here var weight is equal to 3.14. But what happens here, even though we didn't define this as a double or a num, it automatically takes that type. If I uncomment here, boom, we have the type string cannot be assigned to a variable of the type double. Now, if you want to be able to change the value, the data type of the variable, you use another keyword called dynamic. So we have here weight, which is 3.2, but you can change that to weight is equal to car, and then you can change that to weight is equal to true, right? But usually you won't use dynamic to define data types, right? It's safer to go with var or to have here the actual data type if you know what the data type is. And now let's talk about constants. Constants are variables that do not change. They're also known as immutable variables, and the previous section where we're talking about the other variables are known as mutable variable or mutable data, and this here is immutable data. Now to define this unchangeable variables, we use two keywords which are const and final, right? And the difference here is that const is used to define constants when we know the value to assign to the constant beforehand, also called as compile time constant, and final, we define constants when we do not know the value beforehand. Here we have an example of a compile time constant. What's going to happen here, we have constant value, right? Constant, this is called type inference. You don't have to define, you don't have to say constant then int, you don't have to type, sorry, you don't have to type const then int then the name. You just have to have here const, then the name of the constant, and then the value to be assigned, and Dart automatically will know that this is an integer constant. So we have here const value, right? Because we know that the value of our constant will be 7. If I uncomment this line here, we have an error because it says that constant variables can be assigned a value. Now, let's imagine we don't know the type or the value that we're going to assign to our variable. We have here current date. This is a special Dart function that will return the date. You don't have to worry about this now. We will have a look at it in the future. But basically what this does is it returns the date and the time. Obviously, it's impossible to define this manually because you don't know when will the code run or where or what time is it going to be, right? So we are calling this and we are assigning the value to this final. So when this code run, get the actual date and time and assign to this constant and print it. If I run this, here we have the current date and time, and it's correct. Today is the 30th of June 2021. So this was basically it. See you guys on the next lesson. Now let's talk about data types. Well, in Dart we can work with different types of data. As we saw previously, we can work with strings, numbers, booleans, and so much more. So data type is basically what sounds like is the type of data in a very simple way. The root data type or the main data type in Dart is called object, and every other data type is a subtype of this data type. We know that if, for example, you define a variable has a string, you cannot assign an integer to that data type. But there's something called type conversion. For example, let's suppose you want to store this integer age in a variable of the type string. You would have to convert this from an integer to a string like this. And if you wanted to convert from a string to an integer or a double, you could do something like So here we have what's called type conversion. If you want to store a certain data type into a variable of a different data type, you would have to convert that. And for the case of the string, you just have to call toString. All right, and this is how you call a method that's defined inside of an object, but that's a bit advanced. Don't worry about understanding this, but this is basically how you do it. And if you want to convert from a string to a double, and you have to make sure that it's convertible, it's a number, not character, this is how you would do. So this is what we call type conversion. So far we've been performing arithmetic operations only on integers at a time or booleans at the same time, right? But we can in fact perform operations on integers and booleans and sorry, not booleans, double, and many other different types. Now I will just bring you an example of a basic arithmetic operations or operation on an integer and a boolean. So we have here an integer variable called integer value, which is 3, and we have here a double, which is 2. Actually, this is a double, and the compiler will understand this has 2.0 because it's a decimal point number. Now we have a third variable here called operation result, which multiplies the integer value with the double value. Now my question for you here is, what would be the type of the operation result? And the answer is double. Every single time you operate doubles with integers, the resulting value will be a double, right? Because it's simple. Doubles can store every single integer values, but integers cannot store double values. So if this was to be an integer, we would have a lot of issues here. But to test what I'm saying, we can run the code. Again, to run the code, to execute the code, we need to have the main file, the main function, sorry. So the first thing we are going to do in here is print the result. And on our case, the result is going to be equal to operation result toString. Remember to have it toString, convert it to string. And to find the value or the data type of the variable, we will print the results type is, and then this is how operation result dot runtime type. This is everything we need. Actually, this is what is going to return the actual runtime type, but we then have dot toString to make sure that we can print this. And as I was saying, if you have a look here, the result is 6.0, not just 6, and the type is double. Now let's talk about typecasting. Imagine that you have a value of a certain type and you would like to use a property, but that property only belongs to the subtype of that type. I know it was a bit hard to understand, but let me explain it again. You have here a value, a variable of the type num, and you want to check if 7 is an even or odd number, right? Integers, values of the type integers have that property. If I try to directly print here value is even, I will get an error saying that the getter is even isn't defined for the type num. So what I would have to do here is the following. Create another variable called value integer, and we want to use value as int, not as a number or num. So basically this is typecasting. Welcome back. On this video we will talk about strings and a couple string operations. As always, we need the main function here because that's how we are going to run the code. Let's start with defining a string. Actually, you have two ways of doing that, using single quotes and double quotes. And here we have single quotes actually both are single quotes, but the idea here was to have single quotes and double quotation marks. Really, there isn't much of a difference, and it's not like you're going to have a problem. For example, on this third string, we have here ones, one. Since we want to use the single quote sign here, it's required for us to have double quotation marks defining our string here. Good. Another concept is concatenation. Concatenation basically means adding or joining strings together. And for our example here, we can have another string, let's call it fourth string, which will be equal to the first string plus the second string plus the third string. And what happens with this sign here, the plus sign, when you are dealing with strings, this is going to join the strings together. When you are dealing with numbers, obviously it's going to add the numbers. If we were to print the result of this, and as you guys can see here, we just joined all of this, 1, 1, 1, 1. This is what we have here. This is not the only way of doing it. Let's have another example. Let's define another variable. So what this means basically is that this variable is going to be equal to the same contents of the variable plus the fourth variable, right? And this is called an increment operator, right? When you want to add a value to an existing value, you use this combination of symbols here, plus, equal. If you want to subtract, that would be minus, equal. Running the code gives us this output here. And as you can see, we joined this string here with the value of this here. And again, writing this is the same thing as doing something like this. So having this here is the same as having this here. So this line here is equivalent to the line up here, but it's faster to write it this way, obviously, and somehow easier to understand. Now let's talk about interpolation. Interpolation in simple terms is the process of replacing a value inside of a string with a placeholder. Basically, if you want to display a variable inside of a string, you would use interpolation. And how you would go about doing that is like this. Let's imagine we have the variable here called name. So if we want to display the name of the user, right, we can just call the variable here. You use the $sign symbol before the variable name. So instead of writing here, my name is Santos, you just have my name is name, which is the name of the variable. And if we run the code, you can see here, you can see that we have here, my name is Santos. And if you change the name of this variable, you can see that the value changed here. Now we have my name is Homie, right? And this is not just for strings, actually. Let's imagine we have this expression here, age, and we want to print the age. We have here the age is equal to the value here. If we run this code, we have the result here, age is 24. Now, multi-lines. To use multi-lines here, or a string with multiple lines, you use 3 quotes instead of just a single quote or quotation mark, depending on how you call it. So let's have an example here of some dummy text. So what's different about using multi-lines is that when you print the code, the structure of the text is kept. You can see that if we run the code here, the structure of the output is the same as the input here. There are countless string operations. For example, let's imagine we want to convert the name here, Santos, to uppercase. You would have something like, so what happens after you have name, which is the variable name, and you click dot, you have a lot of options here to create a substring, to uppercase, lowercase, trim, and all of this. And these are basically methods of the string object. Again, you don't have to worry about that now because we will talk about that in the future. Just wanted to show you that there are a lot of methods for string objects. And if we print this, you can see that here we have Santos in capital letters. So if you want to dive deeper into string methods or string operations, there's a lot of good content out there. We have this blog here. I will link it to this lesson. You can read it. So they explain how to use a lot of methods here, right? But again, I don't want to just give you guys a bunch of information, and I don't want to make you feel like you have to memorize stuff. We are going to use them when we need them. On this class, we will talk about Boolean operations and Boolean operators and Boolean logic. We have talked about operators before, but only arithmetic operators, and now we are going to talk about Boolean operators. Before we even start talking about operators, we should understand Boolean data type. So I have here a small definition and says that Boolean value can have one state of two, true or false. So basically a Boolean data type is a data type that can store only two values, or true or false. So the states can only be true or false. Here I have two Boolean constants, and we are going to use this on our examples. The one with the true value, we call it yes, and the one with the false value, we call it no. Boolean operators. Boolean operators, also known as comparison operators, are operators used to compare values. Let's start with equality. We use the equality operator to check if two expressions or two values are equal. And the symbol is double equal sign, just like this. A single equal sign is called assignment operator, and this is called a comparison operator or equality. So here we define another constant, another variable called yes is no. So what's happening here? We are checking if yes is equal to no. And obviously this should resolve to false, right? And the parentheses here are not needed. You can write this without parentheses, but to make it easier for you guys to understand, I will include those here. If I run this code, we have here yes equal to no, and this is false because yes is not equal to no. Now we have another operator called inequality operator, and you can use this operator to check if two values or expressions are different basically. And the symbol is the exclamation mark followed by the equal sign. The exclamation mark is also called not operator, so basically this means not equal. And here we have another example, is yes not no, and this should be true. We are printing here the value. Let's see. And as you guys can see, is yes not no. I should change the text here. Is yes not no, which is true. Just remember to change the text here. Now you might be wondering, what is this \n? This is called the new line operator, actually the new line symbol, right? If you don't include this, for example, you're not going to get this blank line here. That's why we use this. So as I was telling you guys, the not or the exclamation mark is also called a not operator, right? And tables the value. So if a value is true and you proceeded with the not operator, it's going to be false. Another way of having this expression here would be something like this. So here we have the expression, same thing. Just remember to change the text to make sure that this makes logic or makes sense. It's logic. Now let's talk about greater than or lesser than operations. I believe that you guys are very familiar with this symbol from math. And the example here would be, let's have two variables, one called 1 and the second one called 2. Now the first thing we want to check is is 1 greater than 2? And this should be false. And then we want to check, is 2 greater than 1? If 1 is smaller than 2, means that 2 is greater than 1. So is 1 greater than 2? Is 2 greater than 1? So for the first example, as you guys can see here, I know that the output is a bit small, but hopefully you guys can see this. Is 1 greater than 2? It's false. Is 2 greater than 1? It's true. Now we have another symbol here, which is lesser or equal than or greater or equal than, right? So you will have the lesser than and greater than symbol followed by an equal sign. So we are checking on the first example, is 1 lesser or equal to 2? And on the second example, is 1 greater or equal to 2? So we are going to print that. Is 1 lesser or equal to 2? True. Is 1 greater or equal to 2? That's false. Now let's talk about something called Boolean logic. Boolean logic is a form of algebra which is centered around 3 simple words or operations: or, and not. Sometimes you want to combine more than one Boolean expression. For example, you want to check if 1 is greater than 2, but you want to check as well if 2 is greater than, let's say, 5. Let's start with AND. AND operator is only true if both operands are true. What this means is this can only be true if the value of yes is true and the value of no is true as well. Since no is false and this is true, the result of this expression will be false. Let's run this code. And as you guys can see here, AND of yes and no is false. Now we have the OR operator. An OR operator is true if at least one of the operands is true. So what that means is OR of true and false is true. And the symbol are these two, I don't know how to call these things here, these two bars. And the symbol for the AND operator is the AND sign, ampersand sign. So let's run the code. AND, but this should be OR, sorry. OR of yes and no is true. And now another thing I want to show to you guys is, do you see how these two outputs are close together? And that's because we do not have this slash and new line here. Now continuing, we have the not operator, and I already talked about this. And what happens here is that if the value of an expression or variable, whatever it is true, and we proceeded with the not operator, the value will change from true to false, or if it's false, it will change from false to true. So basically saying not true is the same as saying false, which is true. Here we have the example. The opposite of true is not true, and this should be false. Another thing I would like to show you guys is how I have this not true inside of the $sign and this curly braces. When you want to print an expression, you have to insert the expression inside of curly braces, just like this. And if you run the code, we can see the output here. It says the opposite of true is false, which is true. Now there's something else called operator precedence. In an expression with multiple operators, which one will be executed first? Let's have this example here, and this looks complicated, but it's not. So we want to check the value of this expression, and basically the expression is 3 is lesser than 5 and 2 is greater than 1, or 3 is equal to 4. Can you guys try to guess which is going to be the output of this expression? So the result of this expression here is true. So we have something called a table of precedence, and it's something like this. Basically what this means is that in an expression, the not operator has the higher precedence. Basically this means that this will be executed first, then we have these operators here, then we have this, and the last thing to be executed is the OR, right? The same way you have operators precedence on arithmetic operations, because you already know if you have, let's say, addition and multiplication, the multiplication will be done first, right? But this is something you can override, and I will show you guys in a second how to do that. So overriding basically is defining for yourself which section of the expression will be executed first. And you do that using parentheses. For example, we have this expression here, the parentheses are at the back. And again, since we want to print the value of an expression, we have to insert everything inside of curly braces. So here the parentheses are back here, and here the parentheses are in front. What's going to happen is that the value or the result of these two expressions will be different. And if you analyze and if you have a look here, you can see that the results are different because here we first did this. So the value of 1 is lesser than 2 is going to be true. 1 is lesser than 4 is true as well. And this is going to be true, right? But if you check 3 is greater than 4, this is false. And then we're going to do false and true, which is going to be false. Thus, we have false here. Now, coming back to this example, we are going to execute this section first. So 3 is greater than 4 is false. 1 is lesser than 2 is false as well. So this whole section is going to be false, but this one is true. So we are going to have here false or true, which is true. Hopefully that was easy to understand, and let's proceed. Hello beautiful people, welcome back to the course. On this lesson we will talk about control flow, and as the name suggests, you use control flow to basically control the flow of the execution of the program, right? Most often than not, you will not want to execute every single thing one after the other. For example, if you want to check if a user of your app is underage, so for example, he cannot access certain parts of the app, right? You would check for the age. If the user is underage, you would do something. If the user is not underage, you would do something else. That was a weird example, but okay. Now, to make that possible, we can make use of the following methods. First, there's something called the if statement. If statement allows the programmer to tell the compiler which section of the code to execute based on the condition. So what that means is that you will check if a particular condition is true, you're going to execute some code. Let's suppose we have here age, right? So how this works is like this. If, and this must be a Boolean expression, right? It must be an expression that returns a Boolean value, a condition. If age is lesser than 18, we want to do something in here. So on this example, it would be if age is lesser than 18, we want to print you are underage. Now, if you have a look here, nothing happens. Why? Because 21 is not lesser than 18. But if I change here the condition and have something like this and run the code again, you can see that now we have you are underage, because it doesn't make sense really, but basically I just wanted to show you. Since 21 is greater than 18, this is not going to execute because this condition is not true. Now there's something called the else clause, and this almost every single time you say an if statement, it's going to be followed by an else clause. It's not required, but usually is like that. So let's suppose we have here the conditional statement. We have if the age of the user is greater or equal to 21, we want to print you can drink. Else, basically, if the age of the user is not equal or greater than 21, we want to print something else, and on this case we want to print you cannot drink. If we execute this code, you can see here that the output says you can drink, because in fact 21 is greater or equal than 21. There's something else called the else if statement. Sometimes you want to check more than one single condition, and let's proceed with our example like this. First, we are checking the following. If the age of the user is greater than 18 and is lesser than 21, we want to print here you are of age but you cannot drink, right? Considering that the drinking age is 21. Or we want to check something else. That's when we use the else if. And here we have the following. If the age of the user is greater than 18 and is greater or equal to 21, you want to print you are of age and you can drink. If we check the output here, we have you are of age and you can drink. Let's see, here we have else just drink water kid. If I change the age here from 21 to let's say 15 and run this code, we have here the outputs. First, for this section here, you cannot drink, you are underage. First it's here, you are underage. When we execute this section here, the output is you cannot drink, and finally we have just drink water kid. Now here I will teach you something called variable scope, and in very simple terms, variable scope is basically where is that variable visible, or where can the variable be used, right? Let's write some code and you will understand that. For example, here we have if age is greater than 18, right? We want to we just declared a variable inside of the if statement. Note that this is inside the if statement. We want to print hello, the name, you are of legal age. We execute the code. This is the output. Hello Santos, you are of legal age. If I try to access this variable, the variable name, outside of the if statement, let me uncomment this line. Now we have this error saying undefined name, which is the name of the variable. Basically, we are saying that the compiler is telling us that this variable is not defined, right? And you might be wondering, how is this variable not defined if I have it here? The problem here is that this variable is defined inside of this local scope here. So it's only visible and accessible inside of the if statement. Everything outside these curly braces cannot see this variable, thus cannot access it. And that's what's called scope of a variable. Now let's talk about something called ternary conditional operator. The majority of the operations we had now, to be honest, all of them, they use two operators, right? Ternary, as the name suggests, we use three different operators. And on this case, this is very similar to an if-else statement, because the way it is structured is like this. We have the condition here on the left side, then we have the question mark, and the first expression here will be the result, or will be the value if this condition is true, and the second here will be the value if this condition is false. Here we have an example. If age, again, the parentheses are optional. If age is greater than 21, we want to print you are of age, else we want to print you are underage, right? And if we execute this code, we would see here you are of age because the value of age is 21 and 21 is greater than 19. Another good thing we can do with the ternary operator is that we can assign values to constants or to variables. For example, I have here a variable called can I vote, and we have age is greater or equal, is greater than 18, right? We want to check this condition. If this condition is true, the value of the variable can I vote will be yes, and if this condition is false, the value will be false or no. So can I vote? And as you can see here, the value of can I vote is true. If I change this, the value here can I vote will be false. Now let's talk about switch statement. Switch statement are usually used, it can be used as a replacement to multiple conditional statements or to multiple if and else statements. And the structure or the form or formula, I don't know how to call it, but the structure of switch statement is like this. We have switch, and here we have a variable, and the difference here is that it doesn't take a condition, it must be a variable. And every single case, for each case here, we have a potential value of this variable. So what we are doing is, if the value of this variable is equal one of these values, we are going to execute some code, and after we are done executing the code, we have this keyword called break. Basically, we are telling the compiler that we executed everything that we had to execute, and now you can break, right? And we have the default keyword here. Basically, this means that if all of these values are not equal to the value we are checking here, just execute the default code here. Let's have an example and you will understand this. Let's suppose we have a variable called menu item number. On our case is 1. And here is our switch statement, right? Inside of our switch statement, we are checking our menu item number. Case the value is 1, we want to print open profile page, then break. Case the value is 2, we will print open settings page, then break, and the default is invalid option. Basically, this means that if we have any other value here that is not 1 or 2, we will print invalid option. If we run the code, you can see here at the very bottom that we have open profile page because the value here is 1. If I change this to 2, as you can see, now we have open settings page, and if we change this to 6, for example, the last value here is invalid option. Now let's talk about enums, or enumerated types. So enums are data type that allow you to create your custom types with a limited option or finite number of options, right? And these are usually used with switch statements. And an example of that would be something like this. This is how you define an enum. You start with the keyword enum. The name of the enum on this case is menu item, and notice that you start with the capital letter. You have your menu item, and here you have the elements or the types of this enum. On our case is profile and settings. Now we are going to create a constant, and this constant will be of the type menu item because this is the is a custom type that we just created, and the default value of the constant item is going to be menu item dot settings. So what we are going to do is we are going to pass this to a switch statement, and for the first case we want to check if the menu item is equal to profile. We want to open the user profile. If the menu item is equal to settings, we want to open user settings, and default will be invalid option. If we run the code, you can see that here we have open settings page, and that's because the value here of the items is menu item dot settings. So this was basically it for control flow. I know that probably too much, but feel free to watch this lesson again if you feel like there's something you need to understand better, and feel free to ask me any question if you have. Beautiful people, welcome back to the course. On this lesson, we will talk about loops. Now, let me ask you a question. What comes to your mind when you hear the word loop? Probably it's something that repeats itself, right? And it's exactly that. Until now, the execution of the code has been sequential. We execute everything from top to bottom continuously. On our previous lesson, we introduced conditional execution or control flow, which kind of breaks a bit the sequence of execution. But sometimes you want to run a certain piece of code multiple times. That's when you use loops. For example, if you want to write a script that adds every single number from 1 to 10, every integer from 1 to 10, you would use a loop to do that. And the first type of loop that we will talk about is the while loop. Basically, the idea behind the while loop is that a certain piece or section of your program will be executed while a certain condition is true. So here we have the syntax. As long as this condition is true, the loop will execute the code inside of the loop. And when the condition is false, the execution of the code will stop. Let's have an example. So what we have here is a variable that we assigned a value 1, right? And as long as this variable is lesser or smaller or equal to 10, what we are going to do is we are going to increment 1 into this variable. And remember that we talked about this sign here. And basically what this means is if the initial value of this variable is 1, then we're going to add 1 to that 1 and it makes it 2. Then we're going to add another 1 and that's 3, right? To make it even easier for you guys to understand, let me run the code and let's see what's the output. Here we have the output, and the first number is 2, obviously, because first we are doing 1 plus 1, that's equal to 2. And we are going to do that until the value of sum is 10, and we are going to add 1 to that 10, which is 11. That's why we have 11 here. But this loop will then start running because the new value of sum will be 11, and 11 is not equal or smaller than 10. Now there is another type of loops called do-while loop, and the main difference between a while loop and a do-while loop is that the while loop will first check the condition and then execute the code, and the do-while loop executes the code then checks the condition. And here is the syntax: do something while the condition is true. In terms of example, I will use the exact same example here. We have a variable with the value 1, and we want to add that sum until the value of sum is smaller or equal to 10. Oh, sorry, here this should be sum 2, and let me comment this code here. So what's going to happen here, the output will be the same, right? Will basically be the same output. And for this example, maybe it's kind of hard to understand the difference, and it may look as if do while and while loops do the same thing, but that's not true, and I will show you that in a bit. Now let's talk about the difference between a do while and a while loop. So I will show you an example where you guys will be able to see the difference. So here we have a while loop, and what we are doing here is while the value 1 is smaller than 6, we want to increment that value, and then we want to print the value. If you see here, if you pay attention, the initial value of the variable value 1 is 7, so this loop is not going to execute because 7 is greater than 6. If I run the code, we will have here the while result is 7. Now let's do the same thing, but now using a do while loop. So we have a second value 2, which is 7 again, and here is the do while loop: do increment while the value is smaller than 6, and then we want to print the do while result. If you guys pay attention here, you can see that the value, the while result is 7, but the do while result is 8. Why? Simple, because this is not going to execute because this condition is false from the jump. From the beginning, this condition is false, but the do while does not check the condition before executing, so it's going to execute this code once, and having this is the same as having plus equal 1. This is an increment operator. This is going to be executed, and then we are going to check the condition. Now let's talk about breaking from a loop, because sometimes you may need to break from a loop after or when some conditions are met inside of the loop. Let's create another variable called value3, right? And here we have the loop. It does the same thing basically. So we want to execute while the value of value 3 is lesser or equal to 10. But in here, let's add something. So basically we are saying that if the value is 5, we want to break from the loop. So we want to exit the loop. Now, if you check the output here, if you have a look at the output, this is the output. We only have 2, 3, 4, 5. And then we break from the loop. So basically here the condition was met, so the loop was broken, and you use the break keyword to break from a loop or a switch statement. Now let's talk about another type of loops which are somehow more popular than the while loops, because normally people use for loops. The major difference between a while loop and a for loop is that when you use the for loop, you know how many times you want to iterate, how many times you want to run the code. And when you're using the while loop, you don't really know how many times you're going to execute the code. You're just going to execute until the condition is met. In simple terms, that's the difference. So the syntax for the for loop is a bit complicated at the beginning, but it's very simple once you understand. So you have your for, and in here, inside the parentheses, we have the initialization, we have the condition and the action, and then the code in here. Let me give you an example so that you guys can understand. So this is how the loop works. Initialization. First, we are creating a variable, and we're going to initialize the value of that variable to 1, right? Condition. While the value of 1 is lesser or equal to 10, we want to execute this for loop. And the action, every single time the code is executed inside of the for loop, we want to increment the value of I, and here we are printing I. If I run this code, here you can see the output is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. this is what this loop is going to do. If, for example, I remove this, now we are only going to have 9 numbers because I must be smaller than 10. And here we have 1, 2, 9. Now the continue keyword. Sometimes you may need to skip some iterations inside of a loop. You don't want to break the whole loop, you just want to skip a particular iteration. For example, if you want to display every single number from 1 to 10, but you only want to display, let's say, even numbers, you would do something like this. So here we have the for loop, then we have an if statement here. Actually, this is the wrong sign. We want to find the remainder. It's not a normal division. Okay, now let's run the code. So as you can see here, we only have odd numbers because when you divide an even number with 2, the remainder is 0. And to get the remainder, this is the operator that we use, the percentage sign. Now, one thing that I want you guys to know is that there are another types of for loops, for example, for in and for each loops. But for me to talk about those loops, I would have to have talked about other concepts such as collections and classes and objects. So we are going to talk about those in future classes or future lessons. Hello beautiful people, welcome back to the course. On this lesson, we will have an introduction to functions. The official definition, or if you search for functions, you will see something like this. Functions are self-contained modules of code that accomplish a specific task, right? Maybe understanding this is a bit difficult, so let me explain it with an example. Let's imagine you want to write expressions to add numbers. So you would do something like this, right? You have the first expression that adds 1 plus 1. And then if you want to add a different set of numbers, you would write a very similar expression, just changing the values here. You will add 23 and 21, and you will add 90 and 1. What's the problem here is that you are basically repeating the exact same code. The logic is the same, right? And let's imagine you want to add 1,000 different numbers. You're not going to write this 1,000 times. So that brings us to this concept called dry, right? And dry basically stands for don't repeat yourself. You have to avoid code repetition. If you have multiple pieces of code that do the same thing, you probably can just create a function out of that code and call that function. So here's the basic workflow of a function. A function basically takes an input, does something to it, and produces an output. Okay, that we may have some iterations on this workflow, but the basic workflow is like this. We have an input, we do something, we have an output. For this example, we would have the numbers as the input, the function would add those numbers, and then would return the result. Here is the syntax of a function. The basic syntax of a function is like this. We have a return type, the function name, the inputs or parameters that are passed inside of this parenthesis, and inside the curly braces we have the function logic, and then we'll return a value, right? The return type can be any data type, can be an integer, a string, a double, or can be empty, what's called a void, right? But you'll understand about that in a minute with more examples. So the first example here will be a multi-parameters function with a return type. Going back to the example that we have about right here, we want a function that's going to add 2 values. That's why we are passing those values here inside of this parenthesis, and these are called parameters. When you define parameters, you usually have the data type of the parameter and the name of that parameter here inside of the parentheses. Now, the operation that we want this function to do is we will create a local variable, and the operation is addition, so we want to add the first value to the second value. After that is done, we want to return result. If you pay attention, result is of type int, and this is the type that we are returning for this function, right? So instead of writing this every single time we want to add two numbers, we can define a function just like this, following this structure, and execute this code every single time we want to add numbers. Now, another example of a function is the main function, and you already know what the main function does. But again, the goal or the objective of the main function is to start the execution of the program. And the structure of the main function is like this. It has no return type. It doesn't return nothing. That's why we have void here. Usually when functions do not return a value, we have void, right? Main is the name of the function. It doesn't have any parameters. We don't need parameters for this specific example. That's why the parentheses are empty. And here inside of the curly braces, we can insert the code or the logic of the function. So in here, we will have another local variable called result, which is going to be equal to add 1, 2. These are called arguments, right? And these words, parameters and arguments, are misused most times, but usually arguments are the values that we pass to the function, and parameters here is the definition of those values. And this is how you call a function. Function name, then the parentheses, and you pass the arguments for that function. Now, if we print result is here, what's going to happen is we are going to add these two numbers, assign the value to this variable, and print the result here. And here is the output. Result is 3. Now, let's talk about a different type of functions with a single parameter and no return type. Let's suppose we have a function called is even or odd, and basically what it does is it checks if a value is even or an odd value. To do that, the logic is like this. We will do value modulus 2, and if the remainder of this operation is 0, that means that the value is even, and if the remainder is not 0, that means that the value is odd. So for this example, we would have here, if this is 0, value is even. If this is 0, value is odd. And again, as you can see, this function doesn't return a value. It operates everything inside of the function. That's why we have here void. Now, inside of the main function, we call the function like this. It's even or odd, and we pass an argument of 3. If we run this code, we have that 3 is odd, which is true. Let's have a different number, 2, for example. And 2 is even, which is true as well. Now, let's talk about optional parameters, right? Because what happens here is if you try to run any of these functions without providing a parameter, let's suppose we have this like this, you'll have an error, and the error says 1 positional argument expected but 0 found. Basically, when we define this function, we have said that we must have an argument here, a parameter here, and we are passing no arguments. That's why we have the error. Now let's talk about optional parameters. So on this case, we have a function called enter name. We require the first name and a last name, right? So what happens here is that when we require an optional parameter, we will have the parameter inside of these brackets here. And every single time we mix different parameters, for example, this is called positional parameter and an optional. The positional parameter must come first, and then we have the optional. So here we are checking for the following. If the last name value is null, we will return only the first name. If the value of last name is not null, we will return the first name and the last name. Coming back here to our example, let's write print enter name, and the name here is Santos. So as you can see here, the value is Santos. Why? Because the optional parameter is null. If we insert Santos and Enoch here has the last name, the output will be different. And the reason why this parameter here is called positional. Let's have a look here at the beginning. These are positional parameters because these values will be assigned based on the position of the argument, right? Because here 1 is the first number, so this will be assigned to the parameter on this position, and this will be assigned to the parameter on the other position. If I run this code here, you can see that we have Santos here because we didn't provide the last name, but here you have Santos Enoch because we have the last name. Now let's talk about default values. Sometimes you may need to have some defaults, some values, some parameters as default values. For example, if the user doesn't insert nothing on that specific parameter, we have a value by default. We have this function here. Looks complicated, but it's simple. It's called enter profile details, right? And usually when you write functions, the function name tells the developer what the function does. That's why the names sometimes are kind of long. Anyways, for the profile detail, we have the first parameter here called name, and we have an optional parameter called position. Basically is the position that that user has in terms of profession. So here the position by default is going to be equal to student. So if this field is not inserted, or if we have nothing for this field, it will default to student. Let's call this function here inside of the main function. Now, if you have a look here at the output, we have Santos position student, right? Even though we didn't provide nothing here. Now, let's try to assign a value to that parameter. So let's pass an argument here called developer. And if I run this code, the output now is different. As you guys can see, now we have Santos name position developer. Now, let's talk about named parameters. You see, the thing with positional parameters is that when you insert values here, when you pass arguments, you don't really know where these arguments will be assigned to unless you know the execution of the function, unless you know how the function is defined, right? But sometimes you want to have the ability to assign each value here to a different parameter regardless of the position. For example, we have here a function named edit profile, and then we have the new name and new password parameters. When the parameters are named parameters, inside of the parentheses we have curly braces, and the named parameter must be defined inside of the curly braces. And then we are going to print new name. We have here the new name, and new password is this. Now, coming to the function call, you have here edit password, new name is equal to Santos, and new password is equal to 123. It doesn't matter if you start here with new password is equal to 123 ABC and new name is equal to Santos, the execution will be the same. If we run this code, you can see that we have here the output, new name, Santos, new password, 123. Now let's talk about mixed parameters. Again, for the second example, we have a positional parameter, which is a name, and a named parameter called position. And what's nice about named parameters is that they are optional parameters as well. So even if you don't pass nothing here, the code will be executed with no problem, right? And every time you have mixed parameters, the first parameters must be positional parameters, and afterwards you can pass the optional or named parameters. So the example here is user details Santos, and this will be assigned to the name, and the position is software engineer. Let me run this code. And as you can see here is the output. And it says name Santos and position software engineer. Now, some tips on how to write better functions. One rule says maximize the use of pure functions and minimize side effects. A side effect basically is when you do something and for you doing that you get something else, sometimes not intended, right? For example, you get sick, you start taking medicines, but then you get fat. That was a side effect of taking that medicine, right? So in terms of functions, if you have a function that is going to alter the behavior of something else outside of the function, that's called a side effect. For example, we have this function here called print hello world, right? This function calls another function called print, and as you can see, print is a function. This function will display the message to the console, right? This is a side effect of calling this function because we execute another function that's going to display something to the console. Another example to make sure you understand the point. Let's imagine we have age here, a variable called age, and then we have a function called void display name, right? The goal of this function is to display a name. But the first thing we do is we alter the value of this variable here. This was not intended to happen, so this is a side effect. Sometimes we may need to have some side effects in the function, right? So I want you guys to understand that. And then we are printing the name, right? What you want to do is you want to minimize the use of this type of functions that will alter things outside of the function. Now, functions with no side effect are called pure function. For example, hello world. What this function does, it returns a text, hello world, and it doesn't alter nothing outside of this function. That's why it's called a pure function. The only task of this function is to return hello world. Another example is username, which does the same thing. We are passing here a parameter called name and it returns that parameter. So there is a principle called single reusability principle, or do only one thing, and this basically states that every single function that you write must be intended to do one and only one task, right? If your function does more than one thing, does 3, 2, 4 multiple things, that's not a good practice. It's better to have a lot of sub functions that do a specific task and call those instead of having one large function that does a lot of things, because it's going to be harder to troubleshoot that function. So that's called SRP, single reusability principle. Choosing good naming. Now, when it comes to naming functions, you have some principles to follow. This is not required, but it's advised, right? First of all, your function must describe what it does. Second point, when you have functions with no side effect, you usually use a noun phrase. For example, on this case, this function just returns hello world. So instead of having get hello world or print hello world, the name of the function is hello world. The name of this function is username, right? But if your function has a side effect, you usually start the function with a verb. For example, this function prints hello world. That's why we have here print hello world. This function displays the username, and the first thing that we have here is display, the verb, right? So these are some of the tips on how to write good functions. Sometimes you are going to execute your function only on a specific section of the code, and on those cases there's no need of defining the function to call it only once. On those cases, again, you use something called anonymous functions. Anonymous functions are functions that can be used without being defined previously. Let's have an example. Starting with the syntax of an anonymous function, you can notice here that the anonymous function doesn't have a return type or a name. And if you return something here, the return type of the function will be defined by Dart using type inference. Anonymous functions are called first-class citizens. That basically means that functions can be assigned to variables, can be passed, has parameters of other functions, and can be returned by other functions as well. Let's have some examples here. Let's see how you would assign a function to a variable. And this is how. Function is a data type as well. So you can create a variable of the type function and assign this anonymous function here. And what this variable will do, basically will have assigned to it an anonymous function that adds two numbers. If you try to do this with a regular function like this, a named function, and you'll see that there's an error because this cannot be done. You cannot assign this function to an integer. Now here inside of the main function, let's have an example of how you would use that. This is a variable of the type function, but when you call it, you call as you would do on a normal function. You just pass two parameters, the numbers to be added, and print the result. And if you execute this code, the output here will be 3, which is the value or the result of 1 plus 2. Another use of anonymous functions is to pass them as arguments of normal functions. And this is how you would do that. Let's suppose we have a function called do something, and this function takes another function as its parameter. So the do something function will take this function as a parameter and will call the function inside of the body. This is how you would execute this. First we call the do function inside of the main function, and here is how we pass the callback function, which is an anonymous function because you can see we do not have the name of the function here, we just have the body of the function. So what this function will do, what the callback function will do is hello there. This is what the function will return, a string saying hello there. If we execute this code, you would get hello there as the output. Why? Because this was called in here inside of the print statement, and since the callback function returns a string, this is what's going to be displayed here. And now let's have another example here on how to return a function. Now on this example, we will build a function that multiplies numbers, right? But the difference between this and a normal multiplication is that here first we will select the multiplier, and every single value will be multiplied with that multiplier. If you didn't understand, no problem, just stick with me here. So first we have a function called apply multiplier that returns another function, and the function that we are going to return here is an anonymous function that takes a value. And what happens, this function returns the result of the multiplication of this value and the defined multiplier here. I know this looks complex, but let's have an example. On our case, we want to triple every single value that we pass to this function. So we will define a variable called triple, and then the apply multiplier value will be 3 because we want to triple. Inside of the print statement, we can have the triple of 4 is triple. And remember that triple is a variable of the type function. That's why it can take parameters. And the parameter we are going to pass is 4. And if you check here on the function definition, we will take the value of the parameter and multiply that with the multiplier. This is the output we get. The triple of 4 is 12, which is correct. Now, another use of anonymous functions is with for each loops. And as you guys remember, I believe that you guys remember, I told you that we would talk about for each loops in the future, and this is the future. Let's suppose that we have a list, and this is how you define a list. We have a list of numbers, right? 2, 3, 4, and 5. Now, what we want to do is for each value of this list, we want to do some operations here. So what we do in here is for each value, we want to run this anonymous function, right? And what the function does, it's going to double the value that we have here. It's going to double every single one of these values here. So the anonymous function is going to print double of value is value times 2. And if I execute this code, you can see the output here. The double of 2 is 4, 3 is 6, 4 is 8, and 5 is 10. By now, I believe that you guys already noticed that every time we define a function, we have the code to be executed inside curly braces. But you can write functions in different ways in Dart. And another way of writing your functions is using arrow notation, right? And this is somehow a simpler way and a cleaner way of writing your functions in Dart. For example, Let me start with a function, a normal function that's not an arrow function. And we have this function here that will add two numbers and return the value. By now, we are very familiar with this type of functions. Now let's convert this to an arrow function. And this is how you would represent the same function, right? There's no need of writing a return here. Automatically, this will be returned. And there's no need for curly braces on this example. And this function takes 1, 2, 3 lines to be defined, and we define this one in a single line. Let's have another example. We had this function on our previous example, apply multiplier, and let's convert this to an arrow function. First, we would have curly braces, and then we would return this expression like this. And as you guys can see, it's simpler to write this function like this rather than having it like this. Hello beautiful people, welcome to object-oriented programming in Dart. This is just an introductory video, and here we will talk about the basic concepts of object-oriented programming. As per the definition, object-oriented programming, or OOP or OOP, is a specific way of designing a program. It allows us to think of data in our programs in terms of real-world objects with both properties and behaviors. For example, let's suppose you are designing a school management system, and you would have to deal with data related to the students. How would you store that data? The built-in data types of Dart and many other programming languages only allows us to store data such as integers, strings, and booleans, but not complex data types such as students. On such cases, you would want to create your own data type, give that data type your properties, and define some behaviors for that specific data type, right? So that's basically object-oriented programming. On that case, the object would be the student. Let's continue, and you will understand everything in a bit. So one of the core concepts of object-oriented programming is called a class. So what's a class, you ask? In simple terms, a class is a blueprint of an object. The official definition says something like a class is a user-defined data type, or is a user-defined type that describes what certain type of object will contain and how it will behave. So if a class is a blueprint of an object, what's an object? Object is an encapsulation of data along with functions to act upon that data. Or object is an instance of a class. To make everything even more understandable for you guys, if a class is a blueprint of a house, the house is the object, or the object would be the house on that example, right? Let's have some code, and you will understand this perfectly in a couple minutes. Defining a class. How do you define a class? Here we have a class called car, right? And to define a class, you first have the keyword class to tell the compiler that you are defining a class name, and then you have curly braces. Inside of the curly braces, we will define class properties, which are these variables here, and class methods, which are functions of that class. On this example, we have car, which is the class, right? And the class car has two properties, make and body type. Make is basically the brand that makes the car, and body type is the body type of the vehicle. So this is the blueprint. Let's create an object. So to create an object of a class, you just write here var car is equal to car. Car is the name of the object, and this could be anything. And here you don't have to write var, this can be a constant, or you can write car just like this. You can specify the type of object that you're dealing with here, the type of class. And as we defined, this is a user-defined data type. So how do you change properties of an object? On this case, our car, the make or the model of the car will be equal to Ford, and the body type of the car will be SUV, right? Because here everything is empty, and here we define the properties for that object. Now let's print the object and see what happens. Now if we print the object, the output will be instance of car. Why? Because the compiler doesn't know how to display the properties of the object yet. The only thing it does know is that this object car is an instance of the class car, right? And you have to pay attention that the object car is lowercase and car, the class, starts with a capital letter. Now, let's suppose you want to display the data related to the car. How would you do that? We would have to override a method. As I mentioned before, every single thing in Dart is an object. So even the class car is a subclass of the class object, right? That would be a bit hard to understand now because we are still introducing the concept of classes, right? But a class can have a subclass or childs. Okay. And on that main class or the parent class object, there's a method called toString, right? We can override the method toString to display something else that it's not instance of a car. Let's have an example. Now here inside of the class, we start with the override keyword to tell the compiler and other developers that this method doesn't belong to this specific class. It belongs to a parent class and we want to override the method. The method that we want to override is a method called toString, and you already saw me working with the toString method. Now what we are going to do here for the toString method, we want to return a string, and the string says car. We have make, where we are defining the brand of the car and the body type of the car, right? Now if we print this again, what's going to happen? Now we have here the output says car name Ford and body type is SUV, right? Previously, the method toString would return the instance that the object belongs to, or the class that the object belongs to, or the class that the object is instantiating, right? But when we override this method, we are basically changing what's going to be displayed when we try to print that object. And I can even change this to say something like, and if I print this, we will have here, this is a car. And what this means is when we create a user-defined type with a class, our program will be able to understand all of this. But if we try to send this data to a database, for example, our database doesn't know what a car type is and doesn't know how to store or to treat that data, right? On such cases, we want to convert the data present on the object car to something that a database can understand. So we would convert this to a string because databases know how to deal with strings. Now, if you pay attention to this example here, we already did that. We already converted this instance to a string, but there are rules widely used to serialize the data. And usually you want to convert your object to a JSON, and JSON stands for JavaScript Object Notation. Probably every single database and APIs will understand how to deal with this data. How do you do that? First, let's create a method. A method is basically a function that belongs to a class. So this is called a method. And the method is called toJSON. And what it does is it returns a string with this strange pattern here, right? This is a JSON object. JSON objects start with curly braces, and the properties are defined inside of double quotation. The value and the keywords, or the value of the property and the property, are separated with a column, right? And every single value or key value pair is separated with a comma, just like this. It may look a bit complex now, but you will you'll understand it even better when we write more examples about this. And this is very similar to a data type in Dart called map, but we are going to talk about maps in the future. So basically, this is how you serialize your objects to JSON notation. Now, if you want to print the data, you would just have here car.json. This is how you access methods inside of objects. And you already seen this by now, right? But since we want to run this method that belongs to this object, we write the object name dot the method name. And method is basically a function. Let's run the code and see what happens. So as you guys can see here, the output is basically the same, but this, since it has the JSON format, that would be very easy to send this data to a database, to an external database. Now let's talk about the cascade notation. Let's have an example. If we want to change the data of the car without using a cascade notation, we would do something like this. We would have car.make, assign a value to that property, car.bodyType, and assign a value to that property as well. If I print this, you can see that the data changed here because we changed the name of the make and the body type property as well, right? But sometimes a class may have a lot of properties, and writing or reassigning values like this may be time consuming. On those cases, you can use the cascade notation, and you would do that like this. And you would have the object name, the class name, and you would have these two periods or these two dots, and then the name of the property you wish to change. You can do this for as many properties as possible, but the last property, it has to be followed by a semicolon, just like this. And if I print this code, I would have something like this. I just don't know if you guys are able to see this, but the data changed again. Here now I have Nissan for the make and SUV on the body type. So this was basically it. This was the introduction to object-oriented programming in Dart. Hopefully everything was clear, but if you didn't understand the point, feel free to ask. I'll be more than willing to help you. See you guys on the next one. Hello beautiful people, welcome back to the course. On today's lesson, we will be talking about constructors. Now, a brief definition. Constructors are methods that create or construct instances or objects of a class, right? We talked about methods on the previous lesson, and we have here some examples. Basically are functions that belong to a specific class. Now, constructors are kind of a special type of methods because first, they always have the same name as the name of the class, and the return type of a constructor is an instance of that particular class. Now, why would we need constructors? For example, if we want to initialize an object of a class with a specific value or with specific properties, we would use constructors on that case. Let's start by talking about something called default constructor. By default, every single class has a constructor called a default constructor, and it's something like this. It looks like a function without a body, and you don't have to explicitly write a default constructor because Dart already understands that every class comes with a default constructor. And let's start talking about long-form generative constructors. Generative constructors can have parameters that are used to initialize properties of that class. And we have long-form generative constructors that are more or less like this. So what we have here is a method with the same name as the class, a constructor. It takes two parameters, one called make, another called body type, and it initializes the values of the make and body on the class, these values here. It initializes them with these values here, right? We have here that the keyword this in the constructor body allows you to distinguish which variable you're talking about. For example, here we have make which is a property of this class, and we have make, which is a parameter of the constructor. When we use this, basically we are saying that we want to initialize this make here, which is a property of the class, with make, the parameter of the constructor. Let's have an example. So now we can call this class the same way we would do with a function, and we pass here the default properties for the car make and the body type. If I run this code, you can see here that the make is Toyota and the body type is SUV. The short form of the same constructor would be like this. And just see how much cleaner this code here. Writing this is the same as writing all of this here. So the short form of the constructor doesn't have a body, right? And the properties are like this dot make and this dot body. Automatically Dart will know that the argument that we pass here will be assigned to this variable here, to this property, and the argument passed here will be assigned to the other property. If you run the code, the output will be the same. Now, these are called unnamed constructors. We have another type of constructors called named constructors, and the syntax of a named constructor is like this: class name dot identifier name. Right, and what's the use of named constructors? For example, you may need or you may want to create a specific type of object, and for that specific type of object you want to initialize the properties of the class with a specific values by default, with specific values by default. For example, we have here car.trucks, and here we are initializing the data. On this case, it doesn't matter the name, but we want the body type of this class, of this class's instances, to be truck. Let's write an example. And on this example, we initialize this object my car with the named constructor. If we run this code, this will be the output. As you can see, we do not have the name of the brand, but we have the body type, which is trucks. Just to make sure that you guys understand this concept, I will have another example. Another named constructor called sedan. And the example would be the same. Now, if we run the code, you can see that all of these objects are instances of the car class, but they have different values. Here for the body type of the car 2 is sedan, and the first one is a truck. So this is an example of named constructors. Now, what's happening here? We are going against one of the principles called don't repeat yourself. The problem here is that these values are initialized on the unnamed constructor, this one, but we are initializing the values again on these named constructors, right? And these may become a problem when we have a lot of constructors doing different things on the same data. To avoid repetition, there's something called forwarding constructors or redirecting constructors. On this case, this is a named constructor, but what it does is that it calls the unnamed constructor, the default constructor here, and it assigns the value like that, right? Let's have an example of this case here. Now, on the surface, it may look like nothing changed, but writing this like this is way better than doing this like that, because the values are not initialized inside of this constructor, but they are in fact initialized using this constructor here. So I would advise you guys to follow this approach here rather than this approach here. Let's talk about named parameters, right? If you guys remember, when we were talking about functions, we talked about positional parameters and named parameters. And that's the same thing with the constructors. An example of using named parameter would be something like this. Now you're going to have an error because you already have defined this here, and you cannot have two unnamed constructors. So now that we remove the other constructor, we would have something like this. And if we initialize an object for that class, we would have something like this. And if you have a look at the example, you can see that this is very similar to how we call functions, right? But basically now we have named parameters on our constructors. Welcome back to the course. On this video, we will talk about initializer lists, and let's have this example. Hopefully you guys are able to understand this because there's nothing new on the screen. But anyways, here we have a class with the following properties: ID, name, and account balance. And then we have a constructor that's going to initialize these properties, and we have overridden the toString method. If I execute this code, so this is basically what we have. But one of the problems with this approach is that someone could just do something like this. And as you guys can see here, I just changed the account balance from 200 to 4,000. And if you had something like this on a real app, this would be a very big problem. There are a couple ways to avoid this. First of all, there is something called private variables. We can create fields that are only visible from inside of the class. And to make a variable private, you just have to precede the name of the variable with an underscore. Now, you have two options here. You can directly initialize the value of these variables, or you could do something else. Now, as you can see here, the names that we are passing through the parameter are not the same as the class properties. And if someone tries to access this externally following the names passed to the parameters, nothing is going to happen because these are not properties of this class. We have an error here because these variables are now private, so you have to change the name and precede them with an underscore. And as you guys can see, it's not possible to just change the value like this. And just like this, we are able to initialize these private variables here with the names from the parameters. And what's good about initializer lists is that this is ran before this object is created. So now if I try to do something like, you can see that now we have a problem because this field does not exist. But for example, if I do something like this, we are still able to get the client balance amount, right? So what's good here is that you are unable to change this value here. You cannot change it, but you can still get the value. And this may be a problem, and it kind of goes against the whole idea of using private variables, right? Let's suppose we want these variables to be hidden so that the user is not able to change or to access the variables. These variables here are only accessible because they are private, yes, but the main file and the class are the main function, the main function and the class client are both in the same file. Now, to make this unaccessible, we would have to remove this class from this file to another. Now we have that file there. How do we use or how do we access the code present in this file on the other file? We use a keyword called import and then the file name. What you want to do here is import then the file path. But when the two files or when the files you're trying to access are in the same folder, has the file accessing them, you just write import and file name. Now, as I was telling you guys, now we have this error. When we try to access the client balance, we have the getter isn't defined, right? Because these variables are private now. We are going to talk about getters and setters very soon, but this is how you make variables private, right? And the only way to access those values, for example, would be to run this code, because the toString method returns the values, but you cannot access a specific field. Now let's have another example. For example, here I've set the balance of the client to be minus 100. If I run this code, nothing is going to happen, and here we have the balance. But if you think about it, it's not super logic to create an account with a negative balance, right? So how do we ensure that some conditions are met? We use the assert keyword. For example, on this case, let's imagine that we want to make sure that the balance is never below 0. So we want to assert that the balance is greater or equal to 0. Let me execute this code. And what happens? We have an error. The app doesn't run. And it specifies where we are having the error. Balance is greater or equal to 0. If we go back to the example and change this to 0 and run the code, everything works as intended. Welcome back to the course. On this lesson, we will talk about constant constructors. Here we have an example that's very similar to what we had on the previous lesson, right? Basically, we have a class with the constructor and an override method, right? And if I run this code, this is the output here. As we discussed on the previous video, even though there's some level of privacy here, because the class and the main function are both here on the same file, we would be able to do something like this. So as you guys can see, even though this variable or this field is private, we were able to change the value of that field, right? Now, to avoid class properties to be changed, we can use the final keyword. What this will do, it will make sure that the value of these fields are only assigned once. That's why we have the error here. And what's even better about this is that these fields don't even have to be private no more. Now, the variables here are public, but they are final. What that means is, if we create an object here, we won't be able to change the properties of that object. For example, if we try to change the brand of the smartphone object after it's created, we will get this error here, because this is a final field. What's the difference between having this constructor here and a normal one? The difference is this. The difference is this: for Dart, all of these three objects that we created here are the same object. Dart will not generate or will not allocate new spaces to store these objects, because it will understand that this object is equal to this object, which is equal to this object. So in terms of performance, it's always better, when possible, to create the constructors of your class as constant constructors. On this lesson, we will talk about factory constructors. Now, up until this point, every single one of the constructors that we have talked about are called generative constructors. That basically means that these constructors only return a new instance of the class on which they are defined, right? But there is another type of constructors called factory constructor, and a factory constructor can return an instance of a class that already exists, or can return a subclass of a class, right? We haven't talked about inheritance and subclasses now, so that may be a bit hard for you to understand, but don't worry about it. A small example of a factory constructor would be something like this. So we start with the keyword factory, and then here I have the name of a named constructor, and the implementation inside will be something like this. Body type will be SUV. And if I run this code, the output will be SUV, right? So this is a introduction to factory constructors, and we will work and use factory constructor from here on, right? I just wanted to kind of give you guys a very brief overview of what a factory constructor is. Hello beautiful people, welcome back to the course. On this video we will talk about getters and setters, right? Now inside of this folder we have two files, the main one and one called student. So here we have some private variables, the ID, marks of the student, and the name of the student. Here inside of the main file we can create an object of the type student. First of all, we need to import student. And just like that, we have created a new student object, an instance of the student class, right? But there's a problem here. Since every single variable here or field of this class is private, there's not much we can do from the main function, right? We are unable to access the student's name or the ID or the marks of the student, right? So if you want to be able to get the value of private properties outside of the class, we use something called getters. And for this example, we would have something like this. And here is how, and this is how you define getters, right? First, we start with the return type of the particular field, ID, the getter name, and the value that it's going to return. If I go back to the main file and do something like now we can access the fields. And as you can see here, student name is Santosh. Now, you don't have to write the exact same field name as the getter. For example, here I can change this to username, and I would have to change the value here to username. But since we already defined that the getter username returns the value of name, the output will be the same. Another thing that I want you guys to know is that the number of getters do not have to match the number of properties here. For example, let's create a new getter called is student smart. So what's going to happen here, this getter will define or will classify the student as smart if the marks of the student are over 80. We have here student name is him smart is true, right? So these are getters. Sometimes you may want to change the value of private variables, because if you come back here and you try to change this, for example, you really can't do much because you cannot change the value of getters. All they do is get the value. On such cases, we use something else called setters. So here we have defined a setter, and how you do that is you start with the set keyword, then the name of the setter, the parameters it's going to take, and the values that are going to be changed. Coming back to the main function, we would have something like this. New name of the student is Mario. And as you can see here, student name is Mario now. So we were able to change the value of a private variable using setters, and we were able to get the value of private variables using getters. So this was it, an introduction to getters and setters. Welcome back to the course. On this video, we will talk about static members. Up until this point, if we were to access properties of a class, we would have to define an object, which is an instance of that class, and then access the property. For example, if you want to access the college property for this class, we would have to create an object of the type student and then access the property using that object. But let's imagine we have a case like this where we have a student class and we have college, but college is common for all of the students. So we want to make college a variable that belongs to the class and not to a specific object. And every single object that is created from this class will have this variable here in common. To do that, we use the keyword static. Now, what's going to happen here, first of all, is that because this variable now belongs to the class, you could do something like this. Now, to access this variable, the college variable, we don't have to create an object. We can access it directly by just using the class name and the college variable name. Let's have another example with this method called display default values. We can see that the college is Bangalore University. So when you use static methods and static variables, you do not have to create instances of the class to access the members of that class, the static members of the class, right? And this is super powerful to use, and you will understand once I give you an example of a pattern called Singleton, which is a design pattern. We will talk about that on the next lesson. Welcome back to the course. On this video, we will talk about the Singleton pattern. The Singleton pattern is one of the most popular design patterns, and it's super simple to understand. A Singleton pattern or a Singleton class is a class that can only have one single instance, right? And this is extremely useful. For example, if you are creating a class for a database that's going to work on your app, you only want one single instance of that database. You do not want to initialize the database when you create a new object of that database class. In the case of classes such as user, obviously you would want to work with normal classes, but classes such as databases and other examples, you usually want to go with singleton classes. And how do you create a singleton class? Now on this first line, we created a private named constructor, right? And this underscore will make it so that this class cannot be initialized normally. So you cannot do this, because it will say that the class doesn't have a default constructor. So you cannot initialize this class like this. Now, if you create a static member of the type database instance that returns an instance of this class, you could do something like this then. Now, this is a singleton pattern, super simple. What happens here is that even if you do this, all of these objects here actually point to the same reference of this class. So if you do this, the class is not going to be initialized or instantiated again. And a cleaner way, even much more cleaner way of doing this would be to use factories. And another advantage of using factories is that you can hide the internal implementation of a class outside of it. For users using your class, calling or instantiating this object like this, it looks like a normal class, but this is a singleton class. And what's better is that if you decide to change this from a singleton class to a normal class, you wouldn't have to change the implementation here. So this was basically it, a very brief introduction or overview of the singleton pattern using static members. Welcome back to the course. On this video, we will talk about nullability and sound null safety. That's a very popular word or term to hear when people talk about Dart 2 and Flutter. But what's sound null safety? In simple terms, null safety basically means that Dart will not allow you to assign the null object to variables. And what's null? Again, in very simple terms, null basically means no value. For example, for you to start with this first example, go to your PubSpec file and make sure that the version of Dart here is 2.10. If it's 12 or onwards, this will not work. So change it to 10 and you'll change it back very soon. Now, coming back to the file that we want to edit, let's suppose we are creating user accounts and we have a field called phone number. And this is the user phone number for this example. So if the user does have a phone number, this is the phone number, right? If the user doesn't have a phone number, maybe we would have a default value for users without a phone number, let's say 0, right? But this is not a very good practice, first of all, because you would have to let other developers know that 0 means no phone number, and you would run into a bunch of issues doing this way. On previous versions of Dart, you could just do this. Now, even though VS Code will tell you that this is not a good thing to do, but you could do it, no problem. And this thing basically means that the phone number field has no value. Let's see what's the problem with doing this. Now let's create a function that checks if an integer is an odd number or even number. And here we have a very basic function that checks if an integer is even or odd. If I run this code, the output will be 2 is even, which is true. If I change this to 1, 1 is odd. But if I change this to null, no error apparently. But let's run the code. Boom, now we have an error. And the error says no such method is even called on null. And this is a very common problem. We as developers, sometimes we assign null to variables by mistake, and this makes our code to break. And what's worse is that you can only know about such type of errors on runtime. Basically, the application will break while it's running, and this is a very big problem. Now, from Dart 2.12 onwards, let's change here the version. What happens is that it's no longer possible to assign null to variables like this. And the error says a value of the type null can be assigned of variable of the type int. And this will prevent our code from breaking while it's running. Now, after I changed my Dart SDK version from 2.10 to 2.12, something happened. A few errors here. And to explain to you what's happening, I will introduce a new concept called nullable types and non-nullable types. What that means basically is that the default types in Dart, int, string, bool, cannot be null. On cases such as this, if you want a variable to be null at times, we have to follow the data type with a question mark. And what this thing means, basically, it's saying that this value here may be null. But of course, the user ID can never be null. So instead of doing this, we can set a default value here. And here we are. So in summary, null-safety basically means that non-nullable types cannot be assigned the null object, the null value, right? And if you want to assign, or if you want a variable to be able to take null as one of its values, you have to follow the data type with a question mark. That basically means that this variable may be null. Let's talk about how to handle null values and type promotion. For example, I have a variable here called name that may be null, and I try to print the length of that variable or the length of the string name, something like this. And normally what this method would do is basically tell you how many characters are in the string name. But since this value may be null, this is not going to run. And this is very good because now this is a compile error, not a runtime error. And you are able to troubleshoot this issue even before you run the code. Now let's talk about type promotion. The Dart analyzer is super smart. Even if we just do this, you can see that now the error goes away. Why? Because the Dart analyzer knows that this value can never be null because we assign a value before we call length. And if I run this code, you can see that the output here is 6, and 6 is the number of characters that we have on this name. Now you may be asking yourself how this type promotion happens or what it means. Basically, when you assign a value to a nullable variable, the type of the variable changes from nullable to non-nullable. So Dart knows that it can use the value or it can access this variable with no concerns because this is a non-nullable variable. It was promoted from a nullable variable to a non-nullable variable. Hello beautiful people, welcome back to the course. Now, continuing on the topic of dealing with null values, on this video we will talk about null aware operators. And the first one, it's called if null. And it's represented by 2 question marks. And how it works is like this. Let's say we have a variable, a nullable variable of the type string called name. Since this variable can hold null as its value, if you want to assign this variable to a non-nullable type, for example, username, what we would do is name, two question marks, default name. What this means basically is that if name is null, we will assign default name string to the username, and the output says default name. And if I were to change this, now we have an error because this value here will never be null because we already assigned a value here. Now let's talk about null-aware assignment. And it's represented by two question marks and an assignment operator or equal sign. Let's suppose we have here double price, which is nullable. And if we follow the previous example, we would have to do something like this. If price is null, the value here that will be assigned to amount. But with null-aware assignment, we would do something like this. And what this means basically, it means that if price is null, we will assign 0 to the price variable. And we could just do this. And now we have here that amount to pay is 0. Now let's talk about null-aware access operator. And it's represented by a question mark and a dot. If we do something like this, and we have this nullable variable called name, if we try to access the length of the string and we use dot length to get the number of characters present on the string, we are going to have an error, right? Because we cannot call length here because the value of name can be null, right? On such cases, we would do something like this. Question mark dot. Basically here we are saying that we are aware that this value may be null. And if we run this code, the output here is null because the value of name is null. Now let's talk about null assertion, and we use an exclamation mark here. And this is not a not operator. Let's see this example. We have int age, which is a nullable variable, and we are assigning age to my age. Basically, having this exclamation mark here, we are saying that age will never be null. So we are telling the compiler, or we are telling Dart to assign the value of age to my age, and we are asserting that age will never be null. On this example, this is not the right thing to do because age may be null, but this is how you do. Now, let's imagine we have a class called user with two properties, a name and an ID, and we will use null-aware cascade operator. If we create an object of the type user here that can be null, this is how we would assign values to that. So this was basically it, a very simple to understand video, and see you guys on the next one. Hello beautiful people, welcome back to the course. On this lesson, we will have an introduction to collections in Dart. And in very simple terms, collections are basically data types that can store more than one value. Basically, data types that can store multiple values. And the first one that we will talk about is list or lists. You have seen lists because we had some examples on previous lessons where we had to use lists, but here we will have a deep dive into lists. So what's a list? A list is an ordered group of objects. Simple as that. Now, how do you create a list? Usually in Dart, you have a lot of ways of accomplishing the same goal. But one of the most common ones is this. Variable list name, and then you have these brackets here, and the list elements go inside of the brackets, and they are separated by commas. And this can store any type of data types. It doesn't have to be integers. It doesn't have to be strings only. It can be integers, it can be bool, and even custom types like user-defined classes. Another way is doing this, numbers int, And what this crazy looking syntax means, basically here, we are telling Dart that we want to store integers into this list. So when you want to define the type of elements that you're going to store inside of a list, you use this generic types. And again, here it can be int, can be a user defined class, any data type is valid. Now, if we do something like printing runtime type, and if you do this variable name dot runtime type, what Dart will do is it's going to return the type of that variable. Let's do that for both lists and run the code. As you guys can see here, the output is list string and list int. Basically, this is a list of strings and this is a list of integers. Now, how do you print a list? Super simple. Just like this, you can have print and then the list name. And if you run the code, the output will be all of the elements of that list. On our case, Dart, Python, Java, and Go. And how do you access items in a list? If you come back to the definition, pay attention to this part where it says ordered group. So a list has a specific order. Every single element inside of a list has an index, which is basically an address, right? And lists start with the address or the index 0. So Dart here is at the position 0, Python is at the position 1, Java at the position 2, and Go at the position 3. Now, to access items in a list, you could do something like this. Element programming language, then inside of these brackets, you have the index number. On this case, we want to access Dart, so you write the list name, then you open these brackets and the index of the element. And now we can print the first item of languages list is, and if I run this code, we have here the first item of the languages list is Dart, which is correct. If you do something like 2, we would have the third item, which is Java. Now, how do you get the index of an item? To get the index of an item, lists come with very handy methods, and one of them is index of. So what you do basically, list name dot index of, and then here you enter the element that you're trying to find the index for. So on this case, we will have the element at the index is programming languages, you open brackets, index. Remember the index is going to be an integer because we will return the index here and we are going to access it here. If I run this code, the output will be the element at 2 is Java. Now, how to assign values to list elements? On this case, our first element is Dart, but we can change that from Dart to something else. On this example, let's change it from Dart to JavaScript. And if we print the list, you guys can see that the first list here is Dart, Python, Java, and Go, but here is JavaScript, Python, Java, and Go. Now let's imagine we want to find the index for Dart, and remember that Dart doesn't exist no more because we replaced Dart with JavaScript. And if we try to print the index of Dart is, here we have the index of Dart is -1. And basically what this means, every time you get -1 has the index of an item in Dart, that means that the item is not present in the list. Now, how do you add elements to a list? Just type the list name dot add and the element you want to add. Now, if we print this list, we will see that at the very end of the list, now we have Dart because we just added the element here. To access list properties or operations, you just have to type the name of the list, then dot. That's how you access methods, because list is a class and it has methods. How do you remove elements? Obviously, list name dot remove and then the element that you want to remove. If we run this, you will see that now this list doesn't have JavaScript. Another way of removing items from a list is using the index. So we would do something like this: list name dot remove at and then the index. From this list, we can see that the second index is the third element. On this case is go. And if I run this code, you can see that go is no longer present in this list. Now let's talk about nullable, mutable and immutable lists. If you have something like this, you may think that because this list is final, this is not mutable. But unfortunately, this is not true. What happens here is that I cannot reassign this variable name to an empty list, for example. If I try to do this, we will have an error. So we cannot change the list itself, but we can change the list elements. What I mean by that is the following. If I remove the element at index 1 and add Next.js to this framework list, you guys can see that I was able to edit the content of this list. So with final, you'll be unable to change the whole list, but you can change the elements present inside of the list. If you want to make the list immutable, you have two ways of doing that. One of them is using list.unmodifiable, and then you pass the list that you want to be unmodifiable. On this particular example, if we try to do IDEs.add value, seems like nothing happens, right? But if you run this code, this will give you a runtime error. Boom. So the bad side about using unmodifiable lists is that they only return runtime errors, so you will find the error when you run the code. Now, another useful list methods or list operations are the following. If you want to check the first element of a list, you can do something like this: list name dot first, and here we have Python because this is the first element of the list. And obviously, if you want to check the last, you would do list name dot last. If you want to check if a list is empty, you could do something like this: list name dot is not empty or list name dot is empty, and this is going to return a Boolean. For this example we have here, does language have elements? And the result is true because programming languages list in fact does have elements. Now, how to loop over a list? Do you remember when we were talking about loops? I said there are two types of loops, one called for each and another called for in. That would be very useful when we start talking about lists. Let's talk about those. For in loop is super simple. So you have here for language in programming languages, basically for an element in a list. On this case, we want to do what? We want to print that language. So for every single language present inside of the programming languages list, we want to print the language. If I run the code, the output will be Python, Java, and Dart. Another way of doing this is for each loop, and we already talked about this. So for each element in the programming languages loop, we want to call this anonymous function that it's going to print the element name. The output will be the same. We have Python, Java, and Dart. There's something super interesting called tear off. Basically, it tears off unnecessary syntax because the output of this is going to be a string and the input of the print function is a string as well. We could do something like, because we know that for this case specifically, the for each loop returns a string and the print takes a string as the input. So you can just have for each and then print. That's a super cool thing that Dart does. And if you run this code, the output will be the same. Now let's talk about the spread operator. Let's imagine that we have a list called development tools. Here we have computer, and then we have this 3 dots, then programming languages, then 3 dots frameworks. What's happening here? Basically, this operator here will take all of the elements of the programming languages list and will add them or will insert them into the development tools list and do the same thing for the frameworks. The output will be something like this: computer, Python, Java, Dart, Flutter, Fast, and Next.js. There's something called a null spread. This is when you are dealing with nullable lists. So for this example, we have a list called first list that can be null, and we have a second list that is going to be equal to 1, which is the first element, and we have the spread operator with the question mark because this can be null. And if the value here is null, this section will be ignored. The output will be 1. Now let's talk about collection if. Collection if is super cool. What it does is it allows us to check certain conditions before adding elements into a list. For example, let's imagine I have a list called my favorite languages, and I have here Dart and Python by default. And then I want to check if English is a member of the programming languages. I want to add English. What's going to happen is, since English is not a member of the programming languages list, this is not going to be added. And if I run this code, the output will be Dart and Python. Let's imagine we have something like Java. And the output now changed. Now we have Java because Java, in fact, is a member of the programming languages list. Now let's talk about collection for, which is super similar to collection if. What it does is that it allows us to iterate through a list and do some operations before adding those elements into a new list. For example, we have here uppercase framework, and this list contains the same elements as the framework's list. The only difference is that all of the elements here are uppercase elements. The output would be Flutter, Flask, and Next.js, but everything is uppercase now. Ladies and gentlemen, this was basically it. Hopefully you liked and understood the lesson, right? And there's a lot of things that you can do with lists, right? But we would need a whole course talking about every single possibility. I just tried to bring what's more common to use with lists. See you guys on the next one. Hello beautiful people, welcome back to the course. On this lesson we will talk about sets and maps. Well, sets are basically a collection of unique items. You probably have seen sets in math, so the same concepts applies here in Dart or in programming in general. So how do you create a set? This is how you create a set. Again, in Dart, you have a lot of ways of accomplishing the same goal. So this is just one of the ways. You define here a set, and this string here, as we saw on the previous video, basically tells Dart that this set will be a set of strings. Here's another example of a set of integers. And here's another example of a set of numbers or num values using type inference. What's unique about sets, again, is that it stores unique elements. For example, it interprets these three values, 1, 1, 1, as one single value, which is the number 1. And you guys will see that in a minute. And with sets, the order of the elements doesn't matter. If I print the prices set, the output will be something like this. And as I told you, as you can see here, we have 1 3 times, but here we only have one value 1. So how do we check contents of a set? Super simple. You just write the set name dot contains and the element that you're trying to check. And here we are checking if this set contains 7. It doesn't, so the output here shall be false. How do we add and remove elements from a set? To remove, you just have to set name dot remove and the element that you wish to remove, and to add, you would do the same thing. How do we add multiple elements to a set at the same time? Super simple. Instead of having one element, we are going to add a list of elements. You can see that the output now includes 8, 9, and 10. One of the most common set operations are intersection and union. Intersection basically Intersection of two sets is another set that contains elements that are present on both sets. For that example, let's print the set prices and the set prices too. So here are the sets. As you can see here, the only common elements that we have are 2 and 8. So if we intersect these two sets, just like this, prices dot intersection prices 2, the output will be another set containing 2 and 8. Union is the opposite of intersection. Instead of just having the common elements, union will join both sets and create another set. The output here will be a union of the prices and prices two sets. Now let's talk about maps. Maps are collections of key value pairs. If that's hard to understand, just think of maps as a collection of variables and their corresponding values. Here is how you create a map. Again, this is just one of the any ways you can do that. In case of the map, you have to define two types. The type of the key, which is more or less like the variable name, and the type of the data type of the value that will be assigned to that key. This is another way of doing it. And if you do this, it's not going to default to a set. This is going to default to a map. And the types of the key and the value will be dynamic because we didn't specify nothing here. So how do you initialize a map? It's something like this. Key value pairs. If you pay attention here, we have a key, which is smartphones, and the value, which is 23. And then we have another key and value pair. Key, value, key, value. So let's imagine we have a map called store stock that keeps track of stock of a particular store, and another map that keeps track of corresponding word to digits. So this example here comes to show that the key can be anything. It doesn't have to be a string. We can have integers, we can have bool, we can have double data types. Here has the key. If I print these maps, this will be the output, and this is super similar to a JSON format. So we have smartphones, which is the key, and the value is 23. Computers, 2. Books, 32. So how do we access elements of a map? Here is how it's done. The name of the map, then we have the square brackets, and here inside of the square brackets we insert the key that we want to access the value of. So on this example, we want to know how many computers we have on stock. So we print the number of computers is computer stock, and computer stock is equal to store stock square brackets computers. If I print this, the output will be number of computers 2. And if you come back here, the number of computers is in fact 2. Now, how do you add elements to a map? Just like this, the name of the map, square brackets, and then the key that we want, the new key and its value. If you run the code, obviously you will see nothing because you have to print the store. If we print the store stock and run the code, you can see that now we have a new key value pair, laptop, and the number of laptops is 7. How do we remove elements from a map? Super simple. The name of the map dot remove and the key that we want to remove. How do we check if a value exists? So we have two options. We can check if a key exists, and that is done by using the method contains key, or we can check if a value exists, and that is done by using the method contains value. How do we loop through a map? Now, iterating through a map is a bit different. For example, you may be tempted to do something like this, and you would have an error, right? And the error says that map is used in for loop must implement iterable. I will explain you in future lessons what implementing iterable means, but basically a map is not like a list or a set. You cannot just iterate through a map and operate it like this. So to have a loop running on a map, you would have to do something slightly different. So instead of iterating through the map itself, you would iterate through the map's key or the map keys. And an example would be for var key in store stock.keys, we want to print the key and the corresponding value. And again, to get the value, we need the map name, square brackets, the key inside. And if I run this code, this is the output here, down here. Another way of doing that is using for each loop. On this case, when we are using the for each loop, the parameters will be the key and the value, and we want to print the key and the value. If I run this code, this will be the output. And one final example or final way of doing this using for in loops is final entry, and we want stock entries, right? And the entry object contains the key and the value. So we can print here entry.key is corresponding to entry.value. And if we print this, we have here the same output. So basically here are different ways of doing the same thing. And this was a very quick overview of sets and maps. Hello beautiful people, welcome back to the course. On this video we will be talking about higher order functions. And in very simple terms, a higher order function is a function that takes another function has a parameter, or a function that returns another function. When we are dealing with collections, there are operators that are basically higher order methods because they take another functions as their parameters. And one of them is maps. And please note that this map is different from map the data type. What this operation or what this property of collections does is basically it's going to apply a specific function to every single element of a collection. And the difference between a map and a for loop, for example, is that a map will return another collection of the type iterable, while a for loop doesn't have to return another collection. Let's have an example. Suppose we have a list of numbers from 1 to 7, and we want to get another list with the triple of these numbers, basically 3 times every single element of the numbers list. What we would do is final triple, which is going to be a collection, is going to be equal to numbers.map, and has the parameter of map. We have here this anonymous function element, and it returns element times 3. If we print this, here we have the output, which is a collection. But if you pay attention here, the numbers are enclosed inside of parentheses. And this is because this is an iterable, not a list. If you want to convert this into a list, you would have to call the toList method. And if I print this, now we have a list here, filtering a collection. This is another element of or properties of the collections, and basically allows us to perform a filter into a collection and produce another collection as the result of that filter. For example, let's suppose we want to create another collection with only even numbers from the numbers list. How we would do that basically is numbers.where, and the function here is element, and returns element is even. The difference here is that the where always takes a function that returns a boolean. If this boolean is true, that element will be added to a new collection, and if it's false, it's going to be ignored. And if we print this, again, the output is going to be this one here. To convert this to a list or set, you just have to call the toList or toSet method, consolidating a collection. Sometimes we want to join every single value of a collection into a single value. For example, if you have a collection of numbers, we would want to sum all of the numbers of that collection. And this is how this is done. We have the reduce method. Let's suppose we have a list of amounts, and to consolidate or to sum up every single element here, we would use the reduce method. And the anonymous function of the reduce method takes 2 parameters, one called sum, that it's automatically assigned with the value of the previous function call, and element, which is the current element that's going to be operated. And here we want to return sum plus element. If I run this code, you could see that the output here is 1495. Another method is called fold. And the difference between fold and reduce is that if a list is empty and you try to run reduce on that list, you are going to get an error. That's why is fold is more reliable than reduce. Let's suppose we have an example called amounts to, and here is fold. The syntax of fold is slightly different because the first parameter is an initial value that's going to be assigned to some, and then we have the function call. So if this list was empty, we would have 0 here, and if we print, the output is going to be the same. Let's try to empty out this list, and if I print, you can see now that the result is 0. Sorting a list. Basically, sorting is organizing a list into a specified order. Let's suppose we have a list of desserts. If we want to organize this alphabetically, we would call sorts on the list. So it would be the name of the list dot sort. And I say list because sort is not applicable on sets. If I print desserts, here is the new list. And sort can be executed on different types of list of integers, list of anything, to be honest. And you can have here your custom logic on how you want to sort the elements of the list. Combining higher order functions or higher order methods. And it's possible to use more than one higher order method on a single operation, just like this. So let's convert the list of desserts into capitals. First of all, we only want to do this for desserts, for dessert names that are higher than 5 in terms of length. And then we want to map those and convert them to uppercase. If I print this, this will be the output. So this was basically it about higher order methods and higher order functions. It was a very quick introduction and overview. You can go in depth in any of these topics here. Now, before we wrap up this section, let's talk about use cases. We have talked about different types of collections, but when do you use them? Simple rule is, for lists, you want to choose them if the list order is important. You're going to use sets if you are only concerned whether something is in the collection or not, and sets tend to be faster than lists. So if the order of the elements is not important, just use sets. You are going to use maps if you frequently want to search for a key and get the value, because this is stored in key value pairs. So that was it. See you guys on the next one. Hello beautiful people. Welcome back to the course. On this video, we will talk about inheritance. So in simple terms, inheritance is the procedure in which one class inherits the methods or attributes of another class. So the class that it's inherited from, it's called the parent class, and the inheriting class is called the child class. Let me use this diagram to explain it to you. On the first example, we have what's called single inheritance, where we have a parent class and a child class. This class here inherits properties from this class here. We have another very common type of inheritance called multi-level inheritance. On this case, we have a parent class, a child class, but a child class has a class or a child class of its own. This is called multi-level inheritance. And you can have any number of classes inheriting from one another here. Now, coming back to the code, this shouldn't be base class here. This is not correct. This is child class or subclass. Anyways, coming back to the code, let's imagine we have a class called car with the following properties: name and production year. Then here we have a constructor and a method that is going to print. This is the brand of the car and the production year. So our previous approach, let's imagine if you want to create another class called SUV, we would do something like this. I mean, another class called truck. If we were to create another class called truck, we would do something like this. Class truck, and then we would have basically the same structure that we have here on the car class. Maybe we would add more properties to this truck class, but it has a lot in common, right? And if we were to create another class called SUV, for example, we would duplicate this class and add different properties. That's not the correct approach. With inheritance, you can do something like this. The class truck extends the class car. So truck is a child of the class car. And to define one class as the child of another, we use the extends keyword. Now here we define the default constructor of the truck class. Notice how we are not using this make and this production year anymore, because this class, the truck class, doesn't have these properties locally. But from the default constructor of the truck class, we are calling the super class. Basically what that means is that the default constructor of the truck class will call the default constructor of the parent class. On this case is the car class. And if you watched the video about constructors, you have seen that we talked about forwarding or redirecting constructors, and what we are doing here is super similar to that. The only difference is that we are redirecting the parameters of this default constructor here to the super class constructors. Now this is where the magic happens, because here on the truck class we can add properties that belong only to the truck class. For example, the bed size of a truck. Now just to make sure that you guys understand everything, I will create another class here called sedan, right? And same thing, the default constructor is going to call the default constructor of the super class, and to do that you just do super and then you call the super class like this. We pass the parameters here and we will add a property called trunk size, right? And the difference is that a sedan car doesn't have a bed, it has a trunk, and a truck, it has a bed. So these two classes are siblings because they share the same parent, the car class. Again, we can create another class called SUV that is going to extend cars as well. And here we have the same thing. The default constructor of the SUV class calls the default constructor of the parent class. Now let's start working with this inside of the main. If we create an object of the type car and call print details on that, run this code. Here we have the details. This is a Ford from 1999. Now let's create another object of the type truck and give it different parameters. Here we have it. What's nice about extending or about inheritance is that the truck class or the truck objects can access methods that are defined inside of the car, just like this. If you go back to the truck class, we don't have print details locally on this class, but since it's a child of the car and the car class does have this method, we can access this method from the truck class. And if I run this code, here I have the output. We can do the same thing for the sedan. Now what's nice is that truck has bed size property and we can change that, and now we can type something like, or we can print something like the bed size of the truck name and then the bed size. Let's see, and here we have it. Now let's talk about overriding methods. You already have seen this, but let's talk about it again. So we are going to take the sedan object and add a trunk size, and then we are going to print get details. Normally just like this, boom, the expected output is here. But if you come here to the class, sedan class, we use the override keyword, we can add a custom body to the print details method. For example, now instead of printing what we have here, class, we want to print something else, and this is the text that we are going to print. Basically the model year, the model name, and then we are going to print the trunk size. If I run this code, here I have the output. The 2005 Suzuki is a sedan with trunk size. Now what we did here, we modified everything inside of the print details class, but sometimes you don't want to change the default behavior of a method, you just want to add your own logic to it, and this is how you do it. Let's suppose we have a class of an object of the type SUV, print details. If we run this code, it's going to print the details as it's expected to do, but we can modify this to do something else. For example, we want to print what's expected, this, but we want to add something else, and then we want to print I love this bad boy. And again, you can do anything here. This is just an example. If I run this code, you will see that we have the default print details behavior, but then we have a custom behavior here that we just added. Now, how to check type of objects during runtime? I showed you one method previously, but there's another way of doing that. You could do something like this. SUV is car. If we run the code, the output will be true because in fact, SUV is a subtype of car, and Dart considers that a car, and in fact an SUV is a car. SUV is truck, and obviously this is false because an SUV is not a truck. If we try to check if SUV is SUV and SUV is object, it's going to be true because everything in Dart is an object or a subclass of object except null. Now, how to check if a variable is not of a specific type? And this is how you do it. You use the exclamation mark. So here we will be checking SUV is not a sedan. And in fact, the output is true because an SUV is not a sedan. So inheritance is good and all, but it has its own drawbacks. People usually say prefer composition over inheritance. And why is that? So the phrase means that when appropriate, you should add behaviors to a class rather than share behaviors with an ancestor. Let's have an example so that you will understand why. Let's suppose we have a class called person, and then we have a subclass of this class called worker. Now we have another subclass called IT professional, which extends worker. Again, multi-level inheritance. Now we have plumber, which extends worker as well. It's a sibling of IT professional. But as you guys can see here, if you want to add a new profession or a role, we would have to create a different class for that. Let's suppose a specific person is an IT professional and a plumber as well. You would have to create another class called IT professional plumber. And let's suppose that person is a YouTuber as well. Then you would create another class called IT professional plumber and YouTuber, right? Which is bad. So what you would do on such situations, you would rather do something like this. So instead of creating new classes, we only create one class called worker. Let me change the name here. And then this class would have a property called roles or positions. And here you would add IT professional, plumber, and everything in between that. So this is a better approach than doing this. And another problem is that inheritance creates tight coupling. And what that means is that when you modify one class, you may break other classes. For example, here, if we add a new property to the car class, let's say number of doors, then the other class is just broke. And here, maybe it's easier to fix, but let's imagine you have a very big application with a lot of classes. That would be a nightmare. So you should pay attention when you're using inheritance. And it doesn't mean that you have to use it every single time and everywhere. For some cases, it's good to use inheritance. For example, here where we have person and a worker, because a worker is a person always. So every single property of the person class will be needed for the worker class. But sometimes here, a plumber and an IT professional may not be a very suitable example to continue using inheritance. So this was basically it, an introduction to inheritance. On our next video, we will talk about abstract classes. On this lesson, we will talk about abstract classes. Well, up until this point, every single type of classes that we used are called concrete classes. And basically that means that we can use those classes to create objects. Abstract classes are different. You cannot instantiate abstract classes. So think of abstract classes as ideas, right? Ideas are abstract, something that you cannot touch. But you use ideas to create concrete things, right? More or less like abstract classes. Maybe that was not the perfect explanation, but in the technical side of things, an abstract class must contain at least one or two abstract methods, which is basically a method that is defined but it's not implemented. It does not have an implementation. If that's hard, just have a look at this example. So we have a class here called animal, right? And to make a class abstract, you have to start with the abstract keyword, then class, and the class name. An abstract class can have a concrete property, just like this one, but it has abstract methods as well. And what we mean by abstract methods or methods with the definition but no implementation is something like this. If you can see here, these methods do not have bodies. They don't have curly braces or code implemented into them, but they can be used. If you think about it, every single animal eats and moves, right? But animals move and eat in different ways. Some swim, some fly, some walk, but they all move, right? Let's continue. An abstract class is still a subtype of object, so you can override methods inside of an abstract class. Let's create a class called duck, which is an animal, so it extends animal. But what happens here is that we have an error. It says that it's missing concrete implementation of these methods. Basically, what this means is all of these abstract methods must be implemented by the concrete classes that extend the abstract class. Basically, what that means is that if you want to extend an abstract class, you must override the abstract methods, just like this. We override the it method, and we are going to print duck its, and the move method. Usually when you create this, you'll have this type of comment saying to do. And to do comments are basically to remind you to implement code into certain sections of your app or project. On this case, we'll print duck moves. And what's good about this is that lay eggs is a method that belongs to the duck class but does not belong to the abstract class, because not every animal lays eggs, but ducks do. Let's have an example. Here we have duck. We created a variable of the type duck, and then we are printing is alive. Again, duck does not have that property here, but childs of an abstract class access the abstract values or concrete classes. What I mean is this: concrete classes, which are child of abstract classes. Basically, a concrete class is a class like duck that you can use to create an object, can access concrete members of an abstract class. Just like this is alive is a concrete member of the animal abstract class. If I print this code, if I run the code, the output will be true. But we can also call duck lay eggs, which is true as well. Now let's do something else. For example, if we create duck2, the type here is animal, but we are assigning duck to that variable, and this works. But what happens when you do something like this is that all of the methods that are defined inside of this concrete class cannot be accessible using this variable of the type animal. For example, if I try to run lay eggs on duck2, we will have an error. But what's fun is that if you print this, Dart will tell you that this is a duck, and the toString method was overridden here inside of the abstract class. So during compile time, Dart kind of doesn't know that this is a duck, but when the code is running, it will identify duck2 as an object of the type duck. That's why when we are calling the toString method here, it says that this is the runtime type is a duck. And another thing, if we do duck2.move, even though duck2 is of the type animal and the move method here is abstract, if we run this code, the move that's going to be executed is the overridden version of move present on the concrete class, duck moves. So this is how an abstract class works. So people, welcome back to the course. On this class, we will talk about interfaces in Dart. Well, interfaces are basically blueprints of classes. What they do is that they define methods and properties that the classes that are going to implement the interface class must have. If that sounds a bit hard to understand, don't worry, you'll understand with an example. Interfaces are extremely useful because they hide the business logic of the code from the implementation. What that means basically is that they can hide how the architecture works from the actual implementation of the architecture. And we are going to have an example here. Let's imagine we are building a weather app, right? And we create a class called data repository. This is just an abstract class that has a method called fetch temperature, and this is a nullable. That's why we have this question mark here. Just as a note, interfaces do not have to be abstract classes. They can be normal classes as well. Now, what this is going to do is the following. We have a class called fake web server, and what this class does, it implements data repository. So when you implement another class, you have to override every single method and property of the class you are implementing. On that case, we will have to do something like this here, and we are returning a value, right? Now, what happens? What's a business logic of an app? Basically, business logic is the core feature of an app. On this particular example, the core feature of the application would be to return the weather based on the city, right? So the implementation of the code would be present in here. The advantage of using interfaces is that we can mock the data. Basically, we can create fake data. On this case, we are just returning 42, but if we were to use a real server, we would do some HTTP requests here and actually return the weather for the given city, right? But with interfaces, we can just do things like this and mock the data. And when we want to take the project to production, or when we want to actually connect to a server, we would just come in here and change the implementation of the code, but nothing else would change outside of this function. We have a city. The example here is Bangalore, which is a city in India. And then we have here repository is equal to fake web server, and the temperature will be repository.fetch temperature for the city. And then we can print the result. If we run this code, we would have something like this. The weather in Bangalore is 42 degrees. Now, what's cool is that we already talked about factories, right? And since data repository is an abstract class, we cannot do something like this, directly calling here data. We cannot do this because we know that we cannot instantiate an abstract class, right? But since we are dealing with interfaces and we have talked about factories, and we know that a factory can return a subclass of a class, we can do something like this. And everything works. From the end user perspective, he's just calling the data repository class. He doesn't even know that this class is an abstract class. But what happens is that this factory here will make it possible so that when someone tries to access the data repository, we return the fake web server, or we call the fake web server. So this is the power of interfaces. The end user doesn't know what happens behind the scenes. He doesn't even know that in fact he is dealing with the fake web server, because here he's calling the data repository, right? And from here we are accessing fetch temperature, and this method is going to be called on the fake web server. And if we run the code, the output is going to be the same, but the end user doesn't know how the business logic of the application works. And what's fine is that, for example, if we create a real web server, another class that implements this, we can just come here and change the class that we return here with a real web server. And we do not have to change the implementation of the code. This is not going to change, but the code in here inside of the business logic may be updated. And this is the power of interfaces. Now, this may look like a regular abstract class, right? Or you may still be wondering what's the difference of inheritance or using extends and implements. And here is the basic difference, right? Let's suppose we have a class, right? And we have a class called another class. My field has a property and it has a method that prints the field. If you extend this class, you will have access to every single property present inside of the class. But if you implement this class, you will have to override every single method and property inside of this class. What I mean by that is that if I remove this, I'm going to have an error. And even if I remove just the variable here, I'm still going to have an error, right? So when you implement one class, you will have to override everything that it's defined inside of this class. But when you extend that class, you are going to have access. You may override some methods if you want to, but you don't have to. And another difference is that in Dart, you cannot extend more than one class, right? You cannot extend, let's suppose I create another class here. So you cannot do something like this. This is not allowed, but you can implement multiple classes like this. And of course, you are going to have an error because you have to implement everything that it's defined inside of the class, just like this. So this was a very quick overview of interfaces and the difference between extends and implements. Welcome back to the course. On this lesson, we will talk about mixins in Dart. Mixins basically provide a way for classes to use properties of a specified class without having to be a subclass of that class. And they also allow classes, unrelated classes, to use common properties and methods. To really understand the need of mixins in Dart, let's follow an example. Okay, let's suppose we have an abstract class called bird, and it has two abstract methods, fly and lay eggs. We have another abstract class called reptile, and it has a method called lay eggs. Now we create a subclass called hummingbird that extends bird. Then first we will have to override everything here. We are overriding the fly method, and we are going to print runtime flies. Basically this will print hummingbird flies. And then we are going to override the second method called lay eggs, and here we have hummingbird or runtime lays eggs. So far so good. Let's continue. Now we have penguin that extends bird, because penguins are birds as well. But then we encounter our first problem when we try to override the method fly, because penguins are birds but they do not fly. Problem number one. And we have to override this method. We really don't have a way around that. And then here we override the lay eggs method again. And finally we have another subclass called snake, which is a reptile, and the snake lays eggs. Now let's create objects for those classes and access the methods available on those. Run this code. Now if you run this code, the good news is that the code was successfully executed, meaning that in terms of syntax there is nothing wrong. But there's a lot of things here that are wrong. Here we have hummingbird flies, which is true. Hummingbird lays eggs, which is true. Penguins don't fly, bro. Penguins lays eggs, and snake lays eggs as well. Now let's take care of the problems that we have. First, this is the most obvious one, but another problem here is repetition, and this goes against the dry principle, which is don't repeat yourself. If you pay attention here, we have lays eggs. This method is exactly the same as this method, which is exactly the same as, and this is a problem, right? Now let's rewrite this using mixins now. Now the first thing to do here is to clear and clean everything, right? Hummingbird is still a bird, and penguins are still birds as well as a snake is a reptile. So this is fine. But on these cases, we would do something else. To create a mixin, we start with the keyword mixin. And let's create another mixin for the egg layers. So here we have our mixins, right? Super simple. Now let's have an example of how you would use that. We have hummingbirds here, and to use mixins, we use the keyword with. Since hummingbirds fly and lay eggs, we will have here bird with flyer and egg layer. Penguins just lay eggs, so we will have here bird with egg layer because it doesn't fly. Reptiles lay eggs, but they don't fly, some of them, at least for this example. And what's awesome about this approach is that we avoid code repetition, because egg layers do exactly the same thing and flyers do the same thing as well. Now let's go back to the example. Now we can do a very cool thing here. Let's override the toString method, and now here we have the final example. As you can see here, inside of the hummingbird class, we can directly access fly and lay eggs methods as if they were defined inside of the hummingbird class, just like this. And for the first example, we will do run type flies and lays eggs. And here I was just showing you guys that you can call the functions directly inside of the string like this using string interpolation. Now let's run the code and see what happens. Here we have hummingbird flies and lays eggs. Penguin only lays eggs, and snake only lays eggs as well, right? So this is the use of mixins. First of all, the snake class and the penguin class are not related. This is a reptile and this is a bird, but they share a common feature. They both lay eggs, right? On such cases, we want to use the same methods on unrelated classes. We use mixins, and this was an example of mixins in action, and hopefully you were able to understand the definition of mixins with this example. See you guys on the next one. Welcome back to the course, and welcome to the introduction to asynchronous programming in Dart. Asynchrony in computer science refers to the occurrence of events independent of the main program flow. Basically what that means is that sometimes you build apps or projects, right, that will connect to databases, will do HTTP requests to servers, or will have to read or write very large files, right? Sometimes you may need to wait to see those operations completing. For example, let's imagine you have a weather app, right? And how it works is that the user inserts the name of the city, and then the app performs a request to a server, and the server is going to return the weather of that city, right? What happens on that case is that after the user enters the name of the city and does the request, you have to wait for the server to respond. Now, having the ability of postponing the response of the server, or just doing something else while you wait for the server to respond, that's what's called asynchronous programming in simple terms. Another term that you are going to hear a lot when you talk about asynchronous programming and programming in general is threads, right? And a thread is a sequence of instructions within a program that can be executed independently of other code. A section of the code of your program, right? A small section or a small group of instructions that are independent from other code in the project are called threads. And in Dart, threads run on these sections or chunks of memory called isolates. Now, another concept is parallelism. So here we are going to compare parallelism with concurrency, right? And parallelism basically means that you is having the ability of running multiple threads at the same time, and concurrency runs one thread at a time. So here concurrency would execute the thread and then another one and then another one. Sometimes it may switch between threads, but it does one at a time, while parallelism can execute one, two, or more threads at the same time. Up until this point, everything that we have been writing is synchronous code. Why? Because we execute the instructions one after the other, right? With asynchronous code, you have the ability of scheduling some instructions or tasks to be executed in the future. In Dart, there's something called event loop. An event loop is what Dart uses or to keep track of tasks that were previously postponed to be executed in the future. To understand this, let's have a look at this diagram here. This diagram is from the Dart Apprentice book, right? And kind of shows the flow of execution of the Dart code, right? Here we have the event loop. We have something called micro task queue, and these are just some internal Dart tasks. We have the main isolate, and this is the code that is being executed. And once a task is entered here, it can't be stopped, and it's executed synchronously, one after the other. And we have something else called event queue. Basically, these are external events like user keyboard strokes, when the user touches on the touch screen, responses from databases or servers, right? So every time we have a new event, it's going to be inserted into this queue. Now, how Dart works: the event loop will be looping, obviously, and first of all, it's going to execute everything that it's inside the main isolate. And when we have a new task inside of the micro tasks, the task is going to be transferred from here to the main isolate. And when the micro tasks queue is empty, the event loop is going to execute what's inside the event queue. For example, if we have new input from the user and stuff like that, this is going to be transferred from here to the main isolate to be executed. If we have new tasks here while the event queue is not empty, Dart will give priority to the micro tasks queue, right? So basically, this is how it's going to work. When we schedule tasks to be executed in the future, this is what is going to keep track of that. And Dart will check if we have something scheduled here to be executed. And when it finds something that is scheduled to be executed, it's going to be transferred from here to the main isolate, right? So this is a very basic overview of how asynchronous programming works in Dart, right? If you didn't completely understand everything, again, don't worry. When we start writing the code, I believe that things are going to be much more simpler to understand. Welcome back to the course. On this lesson, we will talk about futures. On the previous lesson, we had an introduction to asynchronous programming, and on this one, we are going to start working with the practical side of things, right? As I told you, asynchronous programming allows us to reschedule or schedule tasks to be executed in the future, and futures are what make that possible. And in simple terms, again, future is basically a promise. We are telling Dart that in the future we are going to return a value, or we are going to finish executing something in the future. So the syntax of futures is super simple. You have here future, and inside of these angle brackets you have generic data type. You can have any data type here, and then you have the identifier. And this can be used in functions or variables as well. The states of a future data type. A future can be uncompleted, or promise can be, if you're familiar with JavaScript, this is the same thing as promises. Completed with a value or completed with an error. So these are the three possibilities of working with futures. The future is either going to be uncompleted, or it's going to be completed with a value, or it's going to be completed with an error. Let's have an example. I know that this looks a bit complex, but basically what's happening here, this is an example of adding a delay to your code, right? And we have a variable here called myFuture, and then we want to return a string in the future, right? For this example, we are going to use one of the methods of the future type, which is delayed. And then we are going to add the duration that we want the value to be delayed to be returned after. And here we are just going to define an anonymous function that returns an integer. So basically this is how you would work with futures, and after we execute this code you will see what happens. But here we are telling Dart that after a second we are going to return a value of the type integer. We are going to do that in the future. And if you hover over myFuture, you know that you can see that the type of the myFuture variable is a future int. Now, how do you get those values in the future? You have two ways of going about doing this, and one of them is using callbacks. And callbacks are basically methods that take anonymous functions and do some operations on them. Having the same example as the one we have up here, the only difference is that now the name of the variable is myFuture2, right? We have a couple options. First, we have the then method, and it looks like this. We have one called catch error, and we have one called when complete. I know that this looks complex, but it's super simple. Then basically this is going to be executed when the result is returned. The callback function to be executed is this anonymous function here, because all of these properties, all of these methods take anonymous functions as their parameters. We have catch error, and this is going to be executed when the future returns an error. And finally we have when complete. When complete will be executed regardless of the outcome. Even if you have an error or if you have a value, this is going to be executed. And this should take us back to the three possible states of a future. If we have an error, we are going to execute the catch error. If we have a value, the then, it's going to be executed. And after the future is complete, we are going to execute this line of code here. And again, inside of this anonymous functions, you can do anything that you want. But on our case, we are going to print value, print error if you have an error, and print that the future is complete after the future is complete. And at the end here, we want to print after the future. So basically, this is going to be printed before we execute the future, and then we're going to print this. Let me run the code and I'll show you something interesting. Now, if you pay attention to the output here, something kind of weird happened, because we had here before the future, and then this section here was executed after the future, and only after we printed this, the future is executed. So what happened? If you watch the previous video about the introduction to asynchronous programming, we have talked about asynchronous programming being the ability of scheduling tasks to be executed in the future, right? So what happens here, this is executed synchronously, this will be inserted into the event loop, and this will be executed. And after the 2 seconds have passed, this will be removed from the event loop into the main isolate, and this is how it works. So, and this is the power of asynchronous programming. While we wait for this to return something, we could be doing something else, and this is what happened here. While we waited for this output here, we were executing this here. Let me run the code again so that you'll see. You see how we had this almost at the same time, instantaneously. We had this two outputs here, and then only after 2 seconds we had this here, right? So instead of waiting everything and waiting the execution of the code to get the output of the future function, we just skipped this. We executed this section of the code, and when the value was returned here, that's when we printed the value here and we said that the future is complete. Now, another way of getting values from futures is to work with the await and async keywords. Now, how that is done is like this. First, you can see that the main function here is different because it returns a future void, and then we have async. Basically, we use async when we are going to work with future values inside of the function, right? So if the function is going to deal with future values, it has to return a type future. It can be void, but it has to return a future. And we have, after the function name and after the parentheses, we have to insert this keyword here, async, right? Basically means that this function here is asynchronous. Going back to the same example, we have here before the future, and then we have the same method that's going to return 42 after a second. Then we are going to print the value, and then after the future. Now, there's something else happening here. If I hover over the value, you can see that the data type here is int, but if I hover over when I hovered over this previous field here, you saw that the data type was future int. And what makes that difference is this keyword here called await. Because this function is going to return an integer, we are awaiting for the value that's going to be returned from here, and the value is int. That's why this data type here is int and it's not future int. If I remove this keyword and I hover over this, you can see that the data type now changed from int to future int. So when you want to get the actual data type value that's going to be returned, you use the keyword await. If I run this code, you'll see that something happens. Now, unlike the first time where we printed before the future, we skipped this code to execute this and we came back here. When you use the await keyword here, we are actually going to wait to see this code here being executed, and when it's complete, the other one is going to be executed. Let me just increase the duration here and you'll see. And as you can see, we had to wait for 3 seconds and then this was executed. Now, when you follow this approach, when you use await and async, how do you handle errors? Just like how we had this thing here, then catch error and when complete. Now, I'm going to introduce a new concept called error handling, right? And to do that, we are going to use try and catch blocks. They are going to look more or less like this. This is the syntax. We have try, and inside of this block here, we are going to try to do something or to execute a task. Catch. If we do have an error, the code inside of the catch block is going to be executed. And finally, it's going to be executed either with an error or without. So either way, this section of the code is going to be executed. So this is equivalent to the when complete method here, right? This is the syntax. Let's have an example. Before the future, after the future. In here we have the try, and what we want to try, it's going to be inserted in here. If we have an error, we want to execute this code here, and finally we want to execute this code here. Now what we are going to try is the exact same function to return a value after a delay, and then we want to print this value. If we have an error, we want to print the error, and we want to print future is complete after everything is executed. If I run this code, as you can see here, we have before the future, value is 55, future is complete, and then after the future, right? Now there's something called exceptions, and sometimes this is called error handling or exception handling, right? I'll give you an example. Let's suppose you're building a calculator app. You know that we cannot divide a number by 0, right? So you would have that operation here, and you know that sometimes users tend to divide numbers by 0. Instead of crashing the app, because if you don't handle that, the app will just crash, you could create an exception. So basically you would tell the computer that if the user tries to divide a number by 0, instead of crashing the app, execute the code that it's inside the catch statement, right? On our case, how you would throw an exception. On that case, this is how you throw an exception. So let's suppose there is a condition that it's going to cause an error. Instead of stopping the execution, you would write here throw exception and then here the exception name. And what's going to happen is after this line of code here, nothing after this is going to be executed inside of the try. The execution will go directly inside of the catch block. Let me run the code and you'll see that in a minute. And that's why I have the message here saying dead code, because this is not going to be executed. And you can see that we have here before the future, and then we have there was an error, and that's what is printed here. That's the exception. And then what's inside of the finally block is executed, and we have here after the future. So this is a brief introduction into error handling and exception handling, right? But when you use await and async, this is how you would do with every single, you would try to deal with every single possible output of your futures. And error handling or exception handling is not restricted just for futures. You can do this with normal operations as well. So hopefully you guys understood the basic concepts and introductions of this, and we will continue talking about this on next lessons.